Hello. What's up? Good. How are you? Hmm. Okay. Do you have something to discuss today? That's fine. Okay. There's not much to it, is there? Okay. Oh man. Yeah. That thing got me burnt out, man. I worked on that thing so long. Mm. Yeah. That thing's awesome. Yeah. We just get further down the rabbit hole. I got a video today by Master Evo, and it talks about all this stuff. And what Tesla said, it's a paper by Tesla or a lecture by Tesla, and it's just amazing, bro. It's just so much about this high voltage stuff. So, and it showed that today while we're doing the live. Your stream's already live.
All right, let's do it.
but light and matter.
So you're
So
probably right.
interesting. We may get real deep into this. We'll see. I'll let you go.
Hey Ben, you going first with your stuff, or you want me to?
No, no, you go ahead.
Okay, we're going straight live in two, one, and all right, guys, we're live with Old Man Bill's the benefactor, and Gerald's joining us tonight. We're going to talk about a couple of cool things. It's open mic, so give us a shout out. Tell us what you guys want to hear about. But we got some cool stuff planned today. Ben wants to talk about which stuff, Ben?
So, I'd like to discuss my plans for phase 2 testing of the rodent coil system I have, which currently is outputting 155% efficiency, and I want to see if I can utilize that in some way or maybe increase the efficiency even by attaching a Bedini circuit. So, what we're going to do is go through the items list and see what exactly we need. And it's not very complicated, but I need to dot all my I's and cross all my T's here, make sure I got everything on point for phase 2 testing, which is going to be we're going to be charging a battery with another battery, basically. And when I have, I got to find somebody who has a worn out battery that they'd like to dedicate to me, because I do not have one. But when I find one, that's when we'll begin phase 2 testing.
Nice. Very nice. Hey, Gerald, you any closer to getting that coil ready, buddy?
You mean for APEC?
Yeah.
Yep. I'm getting real close. I mean, like, I'm doing crazy stuff that I have to write down because I don't quite understand.
Oh,
That's where I'm at.
that's always good.
Yeah. I'd say so. Like, I can walk around my room. I've got, I can get into it a little bit. If I ground out one side on the secondary of my bifilar coil and I pulse it at a certain frequency, when I walk around my basement, anything I touch that's metal, I get a spark. I get a shock. So it's like the whole area, and I got like a 10 by 12-foot basement area that I'm playing in, and wow, it's crazy.
So, do you get any radiant energy from that?
I imagine that it is all radiant, but I could be wrong on that. I'm still working out that particular piece of data, if you know what I mean.
Yeah.
Am I lighting any light bulbs? Yeah. Let me put it to you this way. When I ground it out, if I grab a ground line and I go to an LED and I take the LED and I go one wire to the coil, it lights the LED. And if I take the second, if I ground one side of the LED and I grab my copper pipe with the other side of the LED, it lights up and I can run it along the pipe and I'll see sparks.
Huh.
Yeah,
That's
so it's
cool.
That's insane. It's like it's like it's grounding it to the metal and then it's building up a charge.
So do you think you're pulling in from the metal or from the ground?
That's an interesting question. I think the coil is energizing the area and polarizing all the metal in the area, and the ground is giving it a path to go. I could be wrong on that, but that's kind of where my head's at this point.
That sounds about right. I mean, you charge everything in the area. I saw a video where a guy used a Tesla coil to charge everything in his house, and he was getting the same thing. So you're getting like the same energy he was getting.
Yeah. But I still have to use like MTech Industries. He does it wirelessly. I'm not quite there yet. I still have to touch one wire to the pipe in the area or any metal that's in the area. So it still has to have a path, but I'm not sure if that's the right route to go or if I continue on and make it all wireless. I'm still working on that.
Interesting.
Yeah, all wireless I think is just a higher rise time on your transistor and a higher fall time as well. So as it's a really fast switching, that allows you to have your wireless. I could be wrong.
Huh. That's pretty cool, man. I like that. It sounds like my garage. You light everything up and everything's charged for a while.
Yeah.
I've had those days.
I like that saying that you said. What was it? Fry it and find out.
Yeah, fry it and find out. That's the way it works. That's right. That's what I do all the time. Unfortunately, it's not on purpose.
Sometimes it should be, though.
Yeah.
Yeah.
All right, guys. I'm going to bring in the video right now. We got Master Evo. So give me 1 second and I'll bring that file in.
Awesome.
In 1891, Nikola Tesla gave a lecture in New York. This essential lecture holds the key to understanding many of his mysterious demonstrations of what he later called radiant energy. He explained and demonstrated in the lecture the disruptive discharge of the capacitor, which produced the current impulse. In this video, I will share quotes from the lecture and explain the principles using my VR 3D whiteboard. I will also give a demonstration with an experiment. Hi, my name is Ivo and I've been doing open source research for the past 8 years, sharing the gained insights in the videos on this YouTube channel. So you can all learn and benefit from them for free. My previous video experiment did not produce power. When loaded, the impedance changed and the current dropped, so no real power was available. But Nikola Tesla talks about impedance effects from his disruptive discharge, so this might hold the key to unlocking the electric power that is needed so hard on this beautiful planet. Let's continue to the lecture. Experiments with alternate currents of very high frequency and their application to methods of artificial illumination. Nikola Tesla delivered this lecture before the American Institute of Electrical Engineers at Columbia College, New York, May 20th in 1891. That's a long time ago, 133 years ago, and still we don't get it. So, let me explain a little bit more about this essential lecture about the powerful electrostatic effects which Tesla used to get his magic working. First, the introduction. Nature has stored up in the universe infinite energy. The eternal recipient and transmitter of this infinite energy is the ether. The recognition of the existence of ether and of the functions it performs is one of the most important results of modern scientific research. The assumption of a medium pervading all space and connecting all gross matter has freed the minds of thinkers of an ever-present doubt. It has been a great step towards the understanding of the forces of nature and their multifold manifestations to our senses. Now, there's a whole part that I'm going to skip through because I want to get to the essential part of this lecture. The lecture deals mostly with the production of light. It's 1891. They are using electricity now, and he has found a way that is very unique, and that is completely vanished from our field of interest, maybe because we don't understand how it worked, but I think he's pretty clear, so I'm gonna skip all that stuff about lightning, but it is the way he did it with electrostatic effects. So electrostatic fields, we know them from when we pull our sweater off and you get this crackling noise. That's electrostatic. It can manifest in materials that are isolators, that can be polarized. But also conductors can produce electrostatic fields. Conductors can be polarized very easily and very quickly. And that's exactly what he did. He built up an electrostatic field around a conductor by providing it gradually a very high voltage, which built up that electrostatic field. And then he suddenly discharged that electrostatic voltage through a spark gap. That's the whole principle. And he's explaining it clearly in his lecture. So let me go on. Many have been carried away by the enthusiasm and passion to discover. But in their zeal to reach results, some have been misled. Starting with the idea of producing electromagnetic waves, they turned their attention perhaps too much to the study of electromagnetic effects and neglected the study of electrostatic phenomena. Naturally, nearly every investigator availed himself of an apparatus similar to that used in earlier experiments, but in those forms of apparatus, while the electromagnetic inductive effects are enormous, the electrostatic effects are excessively small. Yep, that's what I'm missing. Now he talks about the Hertz experiments. And those are electromagnetic induction experiments. And he says the static effects may be considerable, but only qualitatively so, not quantitatively, since their rise and fall is sudden and since their frequency is small. In neither case, therefore, are powerful electrostatic effects perceivable. Basically, he talks about a voltage impulse from a coil. I worked with those for years. And I found out that that's not the way to go if you want electrostatic effects. A voltage impulse.
By the way, guys, just so you know, 2.5x in series gives you electrostatic effects because it lowers the amps, it brings up the frequency, and it will charge everything around you. So you are going to get electrostatic effects.
So I got a question then.
Go ahead.
Electrostatics, is it like voltage without current, or is it strictly charge? It's something I never really figured out.
It's basically potential is what you're looking at.
That's what I thought.
Without current, right?
Yeah, okay.
I mean,
Yeah.
there's milliamps, yeah, but there's not, anything
Not
big.
a lot of it. Oh, okay.
Yeah,
so
there's
there's
really
tiny amounts of current.
Yeah, there's really nothing there. Okay, perfect. Thank you for answering that.
So
Yeah,
so you can create it you just have to know how. And I don't think he's put in the circuit work to do that. He does it in other things, but he didn't put it in this one, where you actually just change the frequency of it and it'll bring the amps way down. And then you'll be able to run it as electrostatic. And it puts off one heck of a charge.
That's crazy. When he says he's building it up and then discharging it real fast, it just reminds me of what the Bedini circuit does too,
Yeah. It's a little bit different. He'll talk about that here in a little bit, but just on the coil aspect, it's this is a bit different.
A bit different, but it's probably a similar mechanism though of action.
No.
No, so it's a completely different mechanism.
Later in this video, he'll talk about. We're just talking about the static effect right now with the coils. So that's separate from what the next part he's going to talk about, which does get into that.
Okay, I don't want to spoil it.
From a coil, an inductive spike, or often called back EMF, goes up and down in voltage. And I explained that in another video, that the displacement of energy then goes back and forward. And he says it won't work that way. Let's continue. When a high-tension induction coil operated by currents alternating only 20,000 times a second has its terminals closed through even a very small jar, and a jar is a capacitor, practically all the energy passes through the dielectric of the jar, which is heated, and the electrostatic effects manifest themselves outwardly only in a very weak degree. Now, I showed you that in my previous video, where I used paper as a dielectric between my capacitor plates, which are coils. And that paper heated up to around 50 degrees Celsius from a high voltage source. So yeah, there goes my electrostatic effect. And so I already came to the conclusion that that paper isn't gonna work. I'm losing my energy there.
Okay, check it out. He didn't pull enough amps out of it. So when he says paper, he's supposed to get a charge. He's getting a magnetic field out of it, which will fry the paper. So when you put two electrodes far enough apart, then you're going to get a charge from it. He's putting it right there, probably too close to the paper, and he's also not taking out enough amps, so he sets it on fire. Trust me, I've done that before.
Oh, so it's too intense.
Yeah, it's just the wrong energy. He's not getting electrostatic.
Okay.
Yeah, he's not getting electrostatic. He didn't pull out enough amps.
Yeah, he's got to burn off some of those amps or reduce them.
Well,
Yeah,
I
he's
know
got to,
it-
he's got to
I know
reduce them.
it's-
That
Okay.
circuit we were talking about, Gerald, where we can change the beat rate or the I'm sorry, I'm drawing a blank here. We change the frequency, we change the duty cycle, and we use a trigger to do it. That circuit we were talking about, that right there would remove the amps from his system.
Yeah, that's the circuit that I want.
Yeah, but that's the one he has to use here in order to get his static effect, and he won't burn any more paper. As a matter of fact, check it out. When I do my experiment, I am getting 5 to 8 times the amount of force than it weighs. So if you can weigh it and it says like 2 ounces, right?
Yeah.
Now multiply that by 8, and that's the force that's being pushed down.
Nice.
Would you say that the system is converting the actual energy into potential when you're decreasing the amps, and then at the other end of the circuit, when you're harnessing the power, it's doing the opposite?
Yeah.
That depends on the circuit.
Yeah.
Go ahead, Nathan. I'm sorry.
Oh, it's okay. It's just that it's charged and it's potential until you introduce heat, then it flips to magnetic.
Oh, I just had an aha moment.
Go ahead.
Okay, because I know you've said that before, but I couldn't quite see it in my mind, and I think I just got it. That heat situation is very important at a specific time. Yeah. Okay, I get that now. That's awesome, Nathan. Okay.
So what exactly does the heat do to the energy?
It converts the charge to amps. It converts the charge to a magnetic field, which converts some of the electricity to amps. Now you've put it into conventional voltage. So basically, when you touch it with your hand in the heat, it converts. Your body is like a battery. Okay.
Yeah.
Mm-hmm.
So you're converting it over by touching it.
Damn, it's instantaneous too. That's why. Wow, now it makes so much sense. That email you sent me now, like I'm mind blown. I get it.
Now you understand why your coil jumped off the table?
Yeah, I didn't think heat was a factor. I really didn't, but you're right, because the coil cools down and it cools the room down. So it's like, wow, okay. Yeah, I'll shut up now and you can continue with the video.
Oh, it's okay. No, all the insight you got, man. Trust me.
That's awesome. That's awesome, Nathan.
If you don't build it, it's so hard to understand it until you see it happen. It was just like me winding that coil. You saw nothing, and all of a sudden everything started shaking.
Yeah, it's like an inrush.
Yeah.
Yeah, it all
Build it, the eddies will come.
Yeah.
But like I said, he has to see it. That's what he's missing. He didn't see it yet. He will. And by the way, paper goes quickly in and out of charge, and it'll charge the air inside of it. So you're getting like an ether effect inside the paper. is what's going on. That's what he's missing. And you can't just be a flat piece of paper. It has to be like I use like a little UFO shaped paper thing, and it has a cavity on the inside where the air is. So
Oh yeah,
it's charging that, and that's the difference. It's like
yeah, that acts as a capacitor at that point.
there you go. So now you're starting to understand. That's why I'm getting so much more. So when you hit the zero barrier in something, you're going to see that you can put more force than what it weighs. So I know it won't lift because I've tried it. It has to have a secondary lift factor to it.
You just blew my mind. I think I've got them. Oh, we're gonna have to talk off live later.
I could show you where it'll pop right off of the stick, man. Has no problem doing that.
Wow. Okay, that's I'm mind blown. I'm really glad I got on live here because I just had like this epiphany of understanding, and I think I know what I've been missing all along.
That's
yeah,
the whole point of this show right here.
absolutely. You want to know what I think it is? I think it's the skin. That's
Skin
it.
effect?
Well, no, like the skin effect is involved in the coil system, but I think in order to pop it up and keep it up, I have to cover it. I have to turn it into a cavity.
Yeah.
And the skin would be the ground system.
Oh, like an
You know
insulation.
what I mean? So, I mean, I don't know. It's just that it's an experiment that has to be tried at this point. My mind's just reeling right now. So I'll let you get back to the video.
Create that cavity, and I think you'll be able to pull off some trick stuff.
Well, there's cavity in the center of the coil because it's open core, right? And then the voltage on the inside of the open core and the voltage that I get on the outside of the coil are different. They're lower than each other. And when you take a laser thermometer and you check the temperature from the center of the open core and the outside of the coil, they're different temperatures.
Yeah, you should be colder inside, right?
Yeah, well, that's just the point. They're different temperatures. And because it's colder inside than outside, it almost seems like it's feeding. I always thought it was just an added little thing that feeds the whole system, like the skin effect and then dichotron instability. It's all these different little things, right?
No, he explains it later on when he starts talking about the vortex and the donut.
Okay, I'll stay out of it. I'll stop talking.
No, it's close to the end of the video, but just watch for that because that's really what you're doing here.
Okay, perfect. I'll stop talking.
That's not the way to go. Better is using air. Best, and he talks about it later, is a vacuum. Now, let me remind you that a vacuum is full of ether. And ether is just another word for energy. So the vacuum is not empty, it is full of energy. Next bit. But powerful electrostatic effects are a sine qua non of light production and the lines indicated by theory. And sine qua non means essential. So he says electrostatic effects are essential. Electromagnetic effects are primarily unavailable for the reason that to produce the required effects, we would have to pass current impulses through a conductor. So he talks about using current impulses. Well, I made a video about that. A current impulse is a singular change, a unipolar change in voltage. And when does that happen? It is with the discharge of a capacitor. So current impulses, capacitor discharge, we need a static field, electrostatic field. That means we need a high voltage capacitor. Long transverse waves cannot apparently produce such effects, since excessively small electromagnetic disturbances may pass readily through miles of air. Such dark waves, unless, and that's electromagnetic waves, unless they are of the length of true light waves, cannot, it would seem, excite luminous radiation in a Geissler tube. And the luminous effects which are producible by induction in a tube devoid of electrodes, I am inclined to consider as being of an electrostatic nature. To produce such luminous effects, straight electrostatic thrusts are required. These, whatever be their frequency, may disturb the molecular charges and produce light. Since current impulses of the required frequency cannot pass through a conductor of measurable dimensions, we must work with a gas. And then the production of powerful electrostatic effects becomes an imperative necessity. It's so interesting to me because he says straight electrostatic thrusts are required. An electrostatic thrust. He's talking about electrostatic thrust. Okay. Thrust does remind me of my own experiments with electrostatic thrusts. The field propulsion video shows this effect. And that video also demonstrates that same current impulse, a slow charge of the voltage and a very abrupt sudden discharge of the voltage. And I demonstrated in that video that if a capacitor is used, then that capacitor is set in motion by that powerful discharge, which produces that longitudinal thrust. I'll include the link in the description below to that video. Okay, we go on. Now it comes. Electrostatic effects being dependent upon the potential and frequency to produce the most powerful action, it is desirable to increase both as far as practicable. It may be possible to obtain quite fair results by keeping either of these factors small, provided the other is sufficiently great, but we are limited in both directions. So voltage and frequency. It might be thought at first that if the bulb containing the filament or button of refractory material be perfectly well exhausted, that is, as far as it can be done by the use of the best apparatus, the heating would be much less intense, and that in a perfect vacuum it could not occur at all. This is not confirmed by my experience, quite the contrary. The better the vacuum, the more easily the bodies are brought to incandescence. And this result is interesting for many reasons. First he goes on explaining how it all works, that he uses electrostatic fields and uses these alternating electrostatic fields to speed up the air molecules that bump into the filament and produce the light. And then he goes on like, yeah, well, actually, in a vacuum, no air molecules, it is more easily.
Okay, guys, check it out. Have you ever seen high voltage in a vacuum?
Yes.
Okay, high voltage in a vacuum produces light.
Right,
Yeah, like
plasma
glow.
bulbs. Isn't that a vacuum tube?
It's just take a regular vacuum, okay, and then you're putting high voltage in there, and say you're making just like a star shape, right? Or any metal shape. Then you hit it with the high voltage on there, and it'll start to illuminate color.
Yeah, it acts like a cloud.
Huh.
Yes. So the reason that works is the high voltage has very little amps in it. It's being thinned out and it's cold.
Absolutely.
So now you see where.
Is that in any way similar to the effects of the Tesla coil has on the noble gas tubes?
No, it like that just lights it up because it's energy by it. This is more like it's static energy inside of a pressurized system. And because of that, it'll illuminate and glow around things. So it doesn't just glow on them, it glows around them.
So like you said, it's moving the molecules and creating the, like as Tesla said, sound waves in the ether to produce the light.
Okay, because there's less energy inside of the chamber because there's less air. Therefore, it has less resistance.
Interesting.
Kind of like thunder and lightning, right? We think that we see the lightning come first and then we hear the thunder. But I propose that it's actually the thunder that goes off, and because light moves faster than sound, we see the light before we hear it.
That's a
But
good analogy, man. I never
it's
thought about that.
just a theory.
It's probably the right one. All right, let's play it some more.
All right.
to produce the light. Whoa. Yeah. Okay, next one. The matter in the globe being radiant, the molecules would move in straight lines. He already talks about radiant matter. That's really interesting. Because this is really at the start of his research into radiant energy, and radiant matter is the movement of the matter that is electrostatic. So, and he says the molecules move in straight lines. So that's a longitudinal motion. But he also referred to the vacuum. Then he says, an interesting thought in connection with such a lamp is that in it, electricity and electrical energy apparently must move in the same lines. Longitudinal. Electrostatic lines that change in potential move in longitudinal ways. It's beautiful. Now he starts talking about the disruptive discharge. Such lamps have been operated by me with current impulses of the enormous frequencies obtainable by the disruptive discharge of condensers. So what he says is you need high voltage for an electrostatic inductive effect. If you want to go low voltage, it won't work. And what is low? Well, in the modern terms, high voltage starts at 1000 volts. And in my experience, it starts working around 4000 volts that you will see some effect of it. But actually 20,000 volts, yeah, you're getting electrostatic effects. You will notice them. Another few pages further on. If a tube be lighted at some distance from the coil and a plate of hard rubber or other insulating substance be interposed, the tube may be made to go out. So he has a coil with electrostatic effects. He has a bulb that is luminescent from that electrostatic induction, and you put in dielectric material like rubber between it, it diminishes. That would not happen with electromagnetic induction. The interposition of the dielectric in this case only slightly increases the inductive effect, but diminishes considerably the electrification through the air. In all cases then, when we excite luminosity in exhausted tubes by means of such a coil, the effect is due to the rapidly alternating electrostatic potential. And furthermore, it must be attributed to the harmonic alternation produced directly by the machine, and not to any superimposed vibration which might be thought to exist. Such superimposed vibrations are impossible when we work with an alternate current machine. Now, what are superimposed vibrations? Such superimposed vibrations are impossible when we work with an alternate current machine. If a spring be gradually tightened and released, it does not perform independent vibrations. So if you have a spring, you compress it, you release it gradually, then it doesn't perform independent vibrations. For this, a sudden release is necessary. So you compress a string and you let it go. So with the alternate currents from a dynamo machine, electromagnetic induction, the medium is harmonically strained and released. And the medium is the ether, the energy surrounding the experiment, the coils. This giving rise to only one kind of waves, electromagnetic waves. A sudden contact or break, or a sudden given way of the dielectric, as in the disruptive discharge of a Leyden jar, are essential for the production of superimposed waves. How clear can he be? Why didn't nobody get this? Or why didn't I? Why didn't I get?
Okay, guys, check it out. So I just wanted to tell you guys this is what's going on with my gravity flyer right now. So my Tesla coil is putting off this charge wave, right? Also, my center plate is putting off the exact same wave. It goes really small and then it builds up really big. And then it discharges into the ether that's created inside the bubble of the gravity flyer.
Yeah, that sounds about right, actually.
Wow. Yeah.
So
That's crazy.
it's showing up, by the way, on my oscilloscope exactly that way. And then when you hit the button on the ultrasound machine to hit the piezo, it creates a longitudinal wave that amplifies both of them right before it discharges.
Yep. That's I've been trying to figure out how to come up with an experiment to actually show that. Like, because what I get out of the coil is I know I get longitudinal waves because I have north and south in the center of the open core, and I have north and south on the outsides, but it stops right at the middle of the coil on the outside of the coil. I'm not sure if I'm explaining that correctly. And if I flip a switch, I can flip the poles. And if I take, say, an iron pole and I stick it just on the north side, that whole pole is just north. Or if I stick it on the south side, the whole pole is south. And then I hit the switch and I can flip them. But other than that, they'll stay south or stay like north. So I don't know. I'm trying to come up with a experiment that's going to kind of show what you're talking about at the same time as what the coil does. I'm not sure if I'm explaining that right.
You know what? Build the little ultrasound device and then put the piezo buzzer to it. And then just hit it when you want it to pop and drive a wave through it. It's going to amplify everything.
You know what happens? I took the piezo buzzer and I stuck it in the center of the open core. And when I turn it on, what happens is I get the Doppler effect. I hear that. And it sounds so cool. But at the same time, I'm not hopping anything up at that point. So I don't know if I have to keep flipping it or hitting it. You know what I mean?
Yeah.
So
you have an oscilloscope?
I do, but it's really tiny. It's one of those cheap $90 ones.
It won't matter. Look for the signal, right?
Okay.
When you see your signal and your coil get to the highest, pop that piezo buzzer.
Oh yeah, okay. I see what you mean.
So yeah, you want to put the biggest pulse. It's like the pyramid. You want to put the biggest pulse when you have the most amount of energy in it.
Okay, well, I can control that impulse that you're talking about on my secondary depending on how I wire it.
Okay.
So like when I do experiments that are high energy, I'll run my primary, like I'll pulse my primary, and my secondary I'll just have a small capacitor bank and a diode on it. And it seems to fill the room with like a pressure. Okay. Your ears almost get to the point of popping. You're swallowing, you're trying to pop. It's like walking up a mountain. And then on my secondary, I'll change that circuit and I'll put a Tesla hairpin circuit on it. And from the Tesla hairpin, I can go to a microwave transformer. And from that, I can light an 800 or 900 watt electric element. So I don't know if it's the static that's coming in or if I'm running off that back impulse.
Do you get a loss of breath?
Yeah, almost like as if the pressure changes in the room.
Yeah,
and I've got witnesses. What's that?
You're converting the air.
That could be. Because sorry, go ahead.
You're not allowing the air to be free as air molecules. Now you're changing them with the charge. So you're changing the system in your garage by pressurizing. You're you're in a vacuum chamber now, is what it sounds like. It's pulling the stuff in and charging the air, so it's no longer breathable. So you're having trouble getting enough oxygen in.
There's another factor involved in that. The experiment I'm talking about right now, I didn't do in the basement. I did in a room where it was surrounded by windows. So there was capacitance, because glass holds capacitance, right?
Yeah.
So I think that might have been a factor in it. I'm not
Glass
sure.
is also an amplification.
So I kind of wonder if I was turning the oxygen into nitrous oxide from all the.
Oh, that'd be bad.
You know what I mean? Like, I don't know. I didn't have any sort of gas measurement systems in play or whatever. So I kind of don't do that experiment very often.
Oh.
I have to do that under a control with a bunch of people monitoring it. I think that would probably be wise.
Yeah, I'd say. Get yourself one of those detectors for your house. You get at Home Depot that says the gases and stuff in your house as a carbon monoxide detector.
Did I look at
Oh, yeah.
Jackie's grandson, grandkid, granddaughter?
Okay, sorry.
No
Other people
worries.
talking. Oh man! All right, let's play some more, man. Let's see what we get.
All right.
Get this. I've been so many years working at it. It's not electromagnetic at all. You can use it, of course. And probably it is needed for the production of electric power. That's what I'm talking about. But that's what I'm after. To be clear, that's the goal of all my experiments, to find out how to do that and share it with you, so we can all benefit and go to the next level of our world. It's about time, isn't it? 133 years later. Okay, let's continue. By using a powerful, rapidly alternating electrostatic field. So that is not a normal form of resonance. Next page. In such an electrostatic field, interesting phenomena may be observed, especially if the alternations are kept low and the potentials excessively high. In addition to the luminous phenomena mentioned, one may observe that any insulated conductor gives sparks when the hand or another object is approached to it, and the sparks may often be powerful. That's pretty fun to watch, I think.
Okay, guys, hold on. I'm going to show you another video here. Okay.
I'd say that it's pretty accurate because those sparks, they bite.
Okay, let's see.
Beautiful.
Just rewind that one more time.
That's the type of electricity that Tesla was using for healing experiments.
Yeah, it's the same thing. It's this Tesla coil that looks like hooked up, and then the wire that comes from it, even though it has a cover on it, it still puts out the energy. My Tesla coil does the same thing when I put the wire down it, and I don't put any kind of thing over top of it.
Okay, so you're putting that wire right down the center of the open core of your Tesla coil, correct?
Yes.
Okay,
Yeah.
so in Wardenclyffe Tower, in that famous picture that Tesla was doing, and it almost seems like he kept all of that out of the patents and everything, but there was a pole in the center of his Tesla coils, but it was always kept out of the picture. You never seen where the ground part went. Then in his notes that I managed to get a little piece of, there was a picture that showed the bottom part, because that was actually he did that with imposing the lightning onto his picture. But underneath where that pole came down and touched the floor, he had a great big huge maybe 1 gauge cable that came off of that. It went off into the background where you didn't see. I think he was using that as a ground. He was collecting energy from that.
Yeah.
Yeah,
Exactly. It's a completely different type of energy than hooking it straight up to your Tesla coil.
Absolutely.
Yeah, it changes things.
It's
You
just
guys,
like, sorry, go ahead.
no, you're good.
It's like when we were talking earlier, and I was talking about the temperature difference between my open core and the outside. Well, if I don't pull power out of the open core heats up. Not the outside, but the center. It heats up. But if I put coils in there and I pull that energy out, then that open core cools down cooler than the outside of the coil. That's what we're talking about when it becomes cold. And when I pull that energy out of the center of the core, it doesn't affect my input current at all. So I think you're onto something big when it comes to temperature. I never even considered it.
Yeah, well, you're pulling a vortex in the center. So you're like a mini tornado and it's colder in the center.
See, and I know there's a vortex that's
That's a
being
great
created.
analogy too.
Yeah, exactly. I can see it with magnet turning, a big deal. I never thought of the temperature differential. That's like mind blowing because it's significant to the whole
It
system.
is. It really is.
Same thing with the Tesla coil, because the Tesla coil, you're literally creating a magnetic confinement of all that static electricity in the center of that coil.
Yeah.
How you're
Tesla like to mimic nature, and the way nature does is it uses that pressure differential. It doesn't create a powerful storm without it. The two counter-rotating vortexes of hot and cold gas or airstream.
honestly, I never ever considered the temperature difference from the beginning of all my research. It never even sunk into my thick skull. I got to thank Nathan for that one.
We gotta thank Nathan for a lot, including this show. This is an amazing show, and without Nathan, we wouldn't be having this show on Monday night. So, we appreciate it.
Thank you. It's all good. You guys want to listen to some more Master Evo?
Yes, but let's say hi to Mike.
Great.
Okay.
Hey, Mike.
Hey, how's it going?
Going good. All right, here we go.
So he has a room with coils and he has induced them with the electrostatic by the disruptive discharge of a high voltage capacitor, single change of voltage, and the coils become electrostatic resonant, let's call it that way, because I'm not sure if it's the longitudinal magnetodielectric mode, but it makes sense. So LMD, and then inside that field, everything becomes electrified from the electrostatic field that is changing rapidly. Very high voltages he mentions and a low frequency. This is also interesting. It is true, the electrostatic effects diminish nearly with the cube of the distance from the coil, whereas the electromagnetic inductive effects diminish simply by the distance. So this is generally accepted and known. But, he says, when we establish an electrostatic field of force, the condition is very different. For then, instead of the differential effect of both the terminals, we get their conjoined effect. What? Electrostatic field of force? Okay.
Sorry, guys, got to interrupt here. This is my gravity flyer field in a nutshell, what he's describing. If you take the Tesla coil and run the wire from the top disc all the way through the center of the Tesla coil to the bottom disc, then you take your high voltage, put it on the center disc, you'll actually be able to take and move the high voltage field that's around the whole craft and push it out. Now, if you flip it back the other way and you put the Tesla coil to the center and you put the high voltage on the disc, you hold in the field. You can control both of them on how big they get. Now, when they interact, it has a higher amount of energy when they interact. So when he starts talking about these fields, that's literally what this thing does.
You know, you just, for some reason, it popped into my head about Otis T. Carr's system with Ralph. oh, I can't remember his last name. He talked about how,
Ring.
thank you. And he talked about how he was in that ship and how they used their mental ability to be able to picture where they were going, and the ship brought them there. And it had to do with an interaction between the high voltage of the ship itself and the person's thought process. So I wonder if Tesla was doing what you're talking about and experimenting with that very same thing. That's just mind blowing. I just had to say that. Sorry, Nathan.
It's okay. Just remember, we talked about that little paper UFO, right?
Yeah.
And it creates something on the inside of it. Okay. More like an ether. So when you look at Otis T cars, just understand the static field's on the outside, charging the entire craft. Therefore, the inside changes. So you're getting more of an ether effect on the inside.
Haha, that's awesome.
So now you can start to see why you go from Otis T car to a paper lifter. You know what I mean? What the transition is and how you create things, because he's got all kinds of frequency bouncing around in this chamber basically, and it's a frequency chamber, or like the inside of a magnetron, where you take the high voltage and then now you're adding frequency to it by the chamber itself and what it produces.
Absolutely. I know what I'm going to do for my next experiment.
What's that?
I'm building a case for one of my coils, and we're going to see what happens.
Oh, you know what? Regular paper, man. See if it'll actually, you know what I mean? Just write around it. Just like build it like a UFO. But
like rice paper or something?
No, just regular paper for your printer.
Really? Okay, I'll try that.
Yeah, it's the way it intertwines together. It's creating I don't know how to say it, like a mesh field.
Yep.
Okay. So you want to do that because it'll place a negative charge on it.
I have a small 4-inch coil I call the UFO because it's actually shaped like one. It lights up like 1,000-watt LED grow light beam, all on its own. So I'm going to use that for that experiment. I'm going to make a cone out of paper, and I'm going to make it like a Utron. That's awesome, Nathan. That's going to be a cool experiment.
It'll change a little bit of how your whole system works too. You'll start getting energy spikes you didn't realize were there.
That will be interesting.
All right, let's listen to the boss one more time and see what he's got.
Is using that electrostatic induction from the disruptive discharge. So actually he is talking about a dynamic effect, and that cumulative wave, that superimposed wave, is from that single direction discharge. Now it's interesting to think about which polarity to discharge, because we can discharge from positive to 0, or we can discharge from negative voltage to 0. There is a difference there, and he has referred to that. The apparatus must be capable of producing high electrostatic potentials changing in value with extreme rapidity. High frequencies are especially wanted, because then you can keep the potential a little bit more down, but still you need high voltages. In the disruptive discharge, we have most generally a fundamental instantaneous variation of comparatively low frequency and a superimposed harmonic vibration, and the laws governing the flow of currents are not the same for both. So what he says is, if you discharge a capacitor in a normal way, not disruptive, then you will have oscillations and you get electromagnetic radiation, the dark energy he talks about. And he says, well, actually that's not gonna work, because you need a disruptive discharge. You need a discharge that is unipolar. So slow charge up and then a fast discharge, but no oscillations. And what then happens is that the electrostatic field surrounding that primary, which has that discharge of voltage, as an energy force field being projected from it, and that provides the accumulative superimposed waves in the secondary. The current impulses may be of any desired frequency. When the currents charging the condensers are of the same direction, so DC, and it is desired that the converted currents should also be of one direction, the resistance of the discharging circuits should of course be so chosen that there are no oscillations. He says the resistance of the discharging circuit should of course be so chosen that there are no oscillations. That's a bit weird. I came to the conclusion that his discharge circuit is the spark gap and the capacitor and the stout copper bar. Here he says with that hairpin circuit, in operating devices on the above plan I have observed curious phenomena of impedance which are of interest. And then finally, but there is a possibility of obtaining energy not only in the form of light but motive power and energy of any other form in some more direct way from the medium, and the medium is ether, energy. We are whirling through endless space with an inconceivable speed. All around us everything is spinning, everything is moving, everywhere is energy. There must be some way of availing ourselves of this energy more directly. Then, with the light obtained from the medium, with the power derived from it, with every form of energy obtained without effort from the store, forever inexhaustible, humanity will advance with giant strides. The mere contemplation of these magnificent possibilities expands our minds, strengthens our hopes, and fills our hearts with supreme delight. And that's the conclusion of the lecture of Nikola Tesla in 1891 in Columbia College, New York. For me, it's very clear. He is so clear. It's an electrostatic effect, and it comes from the change in high voltage on the primary. And the change in voltage is unipolar. It's a current impulse, not the voltage impulse that I used so long. Yeah, I had to learn. Well, there it is. I hope you read it, and I hope you will enjoy what you read and use it to your benefit. I will. Now let's jump into VR and let me explain to you how these concepts work with the electrostatic field. This red part here is a conductor, and I've connected it to a positive 20,000 volts DC. What this will do is create these electrostatic lines of force. They connect this conductor to the surroundings with an electrostatic field. You can see this as a polarization of the ether. These lines are perpendicular to the conductor. So this is the static dielectric field. If I now connect that conductor and source of that positive 20,000 volts to a high voltage capacitor. So I connect the line to this plate, and let's assume that this plate is earth grounded. Then these lines of force, this electrostatic field becomes dynamic. It becomes a displacement current. And these lines, the electrostatic field, will move along that line into that capacitor. So it now starts to move transverse because the field line is in that direction, but it moves sidewards. And it moves sidewards into this capacitor, and it moves in a transverse manner. So now we have the situation that here is the same 20 kilovolts as is on that conductor over here. So there's still an electrostatic field around the conductor, but now it also charged up that capacitor. So this is the positive plate and this is the earth grounded plate. So that 20 kV source provided that electrostatic energy, that high voltage, and it moved sideways around the conductor into the capacitor. Now we can repeat that same thing if we, for instance, remove that 20 kilovolt source and connect here a coil to ground. Then basically we have a shortcut to this plate through that coil. So that electrostatic field, which has a 20,000 volt potential difference between the plates, is now shorted out through that coil. So again, these electrostatic lines of force will move first through this coil. And by doing so, they will take along with it volumes of ether. That is how J.J. Thomson described this in his Electricity and Matter book. And it's all based on Faraday's theory. So these lines of force take with them a volume of ether that is being displaced. And because it's swirling through this coil to ground, this coil will then produce a magnetic field around it, which basically is a swirling volume of ether. Now what Tesla did was not make a magnetic field in his primary. He didn't use the magnetic field. He used the electrostatic field to discharge everything. So back to this situation, we have a high voltage source and the capacitor is charged, and we have that single turn primary here. It isn't even a primary, but let's just take this rod as an example. If we now connect it to ground again, but this time not through a coil, so no inductance, then that 20,000 volt is suddenly discharged. And you would think that they would move sideways again, but it doesn't do that. This time, because the discharge is so rapidly and so fast, it is discharging in the direction of these lines of force, and it creates a longitudinal pressure field. So it expands from all the directions in case of a positive 20 kV. If this was a negative 20 kV, then the discharge would go in the other direction. Then the longitudinal field would be an implosion field into the conductor. So then the field around it collapses inward, and that is if this is negative. So you have a volume of ether that is polarized, that is connected to that conductor, and if it is discharged through a non-inductive path, so not a coil, then you get a sudden change in the electrostatic field that moves along the direction of those field lines, of those electrostatic lines of force, inwards or outwards depending on the polarity. And it creates a expanding field of force or a contracting field of force, an implosion or an explosion of energy. And it is perpendicular to the conductor. The coil and the electrostatic energy, which is built up around that coil, is not moving sideways anymore, transverse, but with the longitudinal static mode, it moves outwards and inwards depending on the polarity change of the voltage. When it goes from positive to negative, it goes outwards, and when it goes from negative to 0 or positive, it goes inwards, like so. 20,000 volts is a lot of volts. This means you will have to work with spark gap, and Tesla was very clear. You need a quenched spark gap so that it doesn't oscillate on the primary. You want a single buildup of voltage and a fast discharge, like so. If you have the axis here, then the voltage this way, positive, will slowly build up into the capacitor, and then fast discharge without change of polarity. So 0 and positive voltage and time. You could also do this in a negative sense. Then you have negative voltage and the time axis. A negative voltage builds up, and then it is suddenly discharged back to 0. And this quick discharge causes that electrostatic movement to be longitudinal. so perpendicular to the conductor. Now we're going to take a look at the electrostatic resonant mode. Red again is a piece of the conductor of the resonant coil, and green is the electrostatic field when resonant. So in this phase of the resonant mode, the electrostatic is maximum. We have pure voltage, and the electrostatic field has been built up around the conductor, which is a polarized ether field. Now, with transverse electromagnetic resonance, these field lines move sideways. And when moving sideways, they drag along ether. And this ether is then moving in a vortex. And that vortex becomes stronger and bigger and larger in volume. And this swirling vortex is the magnetic field. Let me draw it in. So the static field moves sideways, can move both directions depending on the polarity of the transformation, and then the ether is swirling around it like so, and that is the magnetic field that is being built up. Then the electrostatic lines of force diminish in their amplitude, in their volume, in their power, in their energy, and completely transform into the magnetic field, which is that swirling volume of ether. So that is the traditional resonant mode, which we can observe with the normal Tesla coils of today. But Tesla did it differently, as I explained. He used electrostatic induction, creating an electrostatic resonant mode. This electrostatic resonant mode has no magnetic field and no transverse movement of the electrostatic field. Instead, the electrostatic field moves out of the conductor or into the conductor. So it changes amplitude again, but it does this in a stationary electrostatic position. So this means that the force field now is expanding or contracting, like an explosion or an implosion. This creates a different rotation of the, I want to say magnetic field, but this time it is not a magnetic field as there is no swirling action. What now happens is different, and I can best explain it by looking at a donut. Okay, here we have a torus, a ring toroid, a donut. So it has a hole in the center and it's a circular shape. Now, this is a representation of a flow direction of the ether. So here we have a ring vortex. When it is magnetic, these energy flows around that ring vortex in a certain manner which is under an angle, like this. So the diameter of the ring is like so, but it doesn't move in this way. It moves a little bit under an angle, and that is the magnetic field, and this creates that twisting because it is twisted in its nature, because it's everywhere moving inwards like so. So you have an influx of energy that is circulating around. So this would be a north pole and that would be a south pole, depending on the flow direction. And this is due to that electrostatic field moving sideways. That causes that angle of the magnetic field moving over it. So if we now have a movement which is stationary, then the energy moves in the circular manner, which is just closed loop around that toroid. And then you have a different energy flow. It is closed looped, as I said. Oh, sorry, those arrows are...
All right, guys, I'm going to pause it right there. Gerald, I just wanted to show you that point of that what you're creating is the other one, not this one, but the one right before it.
Yeah, yeah, absolutely. It's the other one before it, and it's standing vertically, right? So, because mine isn't a toroid. A lot of people think the one that I show is a toroid. It's not. It looks like a toroid, but it's every platonic solid that you could possibly think of and a little bit more. So it's different than what he's explaining, but at the same time, that principle is the same.
Yeah.
Yeah, well, the idea is that you're cycling the current and you're locking it up in a very complex geometric physical structure that takes place due to the geometry of the windings themselves. So,
Hey, Jeremiah!
Hey, buddy, what's up, man? It's been a while. How you doing? I missed the early part of the show. I want to apologize. I kind of, jumped in. So I was on another meeting. We were talking about mercury vortex generators and mercury vortex engines using parametric equilibrium systems and trying to generate unidirectional force from a nonlinear acceleration of the physical liquid mercury, and how we would actually accelerate it while keeping it inside of an enclosure that wouldn't just blow all the mercury out the sides and create a massive, disaster that has other implications. Anyways, so I'm sorry I was a bit delayed in jumping into the show, but yeah, I did get a chance to watch Master Evo stuff, and he is absolutely excellent as far as genuinely trying to dive into Tesla stuff. He's got a couple of ideas that really stand true to what Tesla was doing, and he's also got some ideas that diverge too far, and they're not actually taking into account some of the effects of Tesla's more, I would say more recent or very last ideas about the electrodynamic forces that take place in what is now just sort of recently coined Tesla's dynamic theory of gravity. So in Tesla's dynamic theory of gravity, if you transmit electromotive force from a single point and it follows a gradient outwards, there is an inwards gravitational force equal to the energy density of the electromotive force that's being released from that point. So if you have, say, an antenna or something that, like in a center plate of a gravity flyer, is oscillating with a high voltage force, you have an electromotive gradient surrounding that center plate. And as a result, you end up with this stress energy that's surrounding the plate, where you have an inward attraction towards the center of the plate. And even though that itself won't necessarily cause any kind of net gravitational weight loss or weight gain, if you combine that with unbalanced charges, then they interact with what many have coined the quantum vacuum or the aether, and as a result, virtual charges, or what are called virtual charges, which in my theory are actually physical charges bound into a fine state, which starts out as positronium and falls into the finest scale possible at the Planck scale, setting up a Planck node. You end up with the ability to tilt and twist each of these little node points within a lattice structure of the vacuum background. So what I'm proposing is that the vacuum itself, it has a physical structure, and we can change the orientation of each node point in that structure and use it to modify the vacuum refractive index. So we could create, say, a force beam, a gravitational beam, or we could create a lifting force through a gradient.
Oh yeah, we were just getting to that when we were pulling down Ebo's video. It's like everything's kind of been coming together in the last 3 months about all this work, and now it's being explained in different ways. It's all the same principle. It's been around for over 130 years, I think, but 130 for sure. It's basically the interaction between electrostatics and magnetics in the environment. And if you can manipulate that, well, maybe we'll float. Maybe we won't. I guess we're going to find out soon, right?
There we are.
You'll float too.
Absolutely. I see, just as a comment, Taryn is in the comment section here on, well, I'm not sure whose channel he's on right now. Probably yours, Nathan. But anyways, talking about the flame jet generator. So Taryn and I, we did some collaborative work on the flame jet generator of Thomas Townsend Brown. And there have been others that have tried to replicate it. Well, we replicated it, and what we found is if I inject only about, I would say 15,000 to 20,000 volts into the flame of one of those little micro torches, and the micro torch is isolated thoroughly up on some insulating material, so it's ground isolated, and I connect a high voltage output wire of my high voltage power supply to the metallized tip of this little micro torch, then I can inject ions into that flame. And what happens is, because the flame thermodynamic energy is so high, I can inject 20,000 volts, but what will happen is if I have the flame off and I inject 20,000 volts, the effective field is about 2 feet away. If the flame is on, the effective field instantly reaches every single wall and corner of the room in a fraction of a second and can light up neon bulbs and all kinds of other fun stuff. So in order to account for the added electromotive force, you would have to justify that you have the effective voltage amplification of over 1 million volts coming from a little flame from a turbo torch.
I remember that experiment.
It's one of those simple things that, yeah, it does. It speaks to the idea of how you can sort of steal energy from one type of system and add it to the other. So in this case, we're stealing the thermodynamic energy of converting a hydrocarbon into an oxidized state and carbon dioxide, and in turn, we're adding acceleration potential to the free charges that are being released from the tip of the flame.
It sounds like
Pretty cool stuff.
sorry. It sounds like what my gravity flyer is doing. I was telling everybody earlier. I'm building up a potential. It goes from small to really big, just like a Tesla coil, and then it discharges. So the gravity flyer itself is putting out the same signal as my Tesla coil. Now, both discs are both putting out the same signal as well with the high voltage. If you hit them at the right time with the piezo buzzer actually amplifies all of them at once. So you get every single part in this craft hitting at one time if you can time it just right.
Right. Well, you ultimately, you don't want to just have everything hitting, all slamming together at once unilaterally. You want to have a standing wave that sort of continuously moves in one direction. So, well, I guess you would call that a traveling wave. So you want to have a traveling wave that's going to produce a change in the refractive index that moves the entire craft upwards as the wave travels downwards, and you're sort of reaching equilibrium. So in terms of the virtual particle pairs, you're effectively splitting them on the top. Positrons fly from the top down to the bottom. And this is not necessarily physical particles that are actually traversing the distance, but this would be the stress in the refractive index, where you're tilting the gravitational plane in such a way that it forms a torus structure around the entire geometry of the system. And as a result, you're transferring momentum from the top plate via rotation down through a field that otherwise doesn't exist on a three-dimensional plane, but exists on a fourth-dimensional plane due to the fact that refractive index has changed. It's like a gravitational field. And then transferring it to the bottom, so the net result is that you get an upwards momentum.
Yeah, that's what Master Evo was talking about, but he considered it electrostatics. That's awesome.
It's one way to do it with the electrostatics. It's probably the easiest way to do it. Back in, I don't remember what year it was. So sorry, but George Pigott did a little experiment where he had what was claimed to be a 500,000 volt electrostatic generator. It was like a Wim-Source machine, but he had it in a pressurized CO2 filled container, so that he could get way higher voltage with no arc over or anything like that. Basically, it was before sulfur hexafluoride was used in high voltage switches, right? He was using pressurized CO2 to get the same kind of effect where you could run it at higher voltage. So he got 500 kV out, and he had some terminal that was about 1 meter off the floor, and it was a curved surface, and then on the bottom he had a large flat plate, and between these two he would place these 1 centimeter wide spheres. One of them was made of I guess it's like a hollow sphere, sort of like a hollow steel sphere. Another one was made of like a cork that was coated in copper foil, and allegedly he got to the point where he was able to actually levitate a solid iron sphere.
Wow.
But that was not. But what he reports is that around the equator of these spheres that were levitating exactly center between the top plate at 500 kV from his CO2 pressurized Wimshurst that was motorized and the ground plane, is that they would have this dark ring around the center, and they would have a corona on the top and the bottom. And it sort of stands to reason that you would have two toroidal structures, almost like the gravity flyer. And you're considering that if there's a difference in potential on the top, you have this positive charge, and on the bottom you have this negative charge, and in the center you have this physical metallic levitating structure. So it's like one of the oldest cases I can think about, and it's actually referenced in a book that I have on how to build high voltage or electrostatic influence machines. So it's pretty cool stuff. And my main point to bring this story up is it's been done for a long time, and it's funny that what we're really doing here is rediscovering what's already been achieved. It's just so much rediscovery, and it shocks me to think how much was lost.
So much was suppressed too, you know. Think of the ether. We don't teach that in schools, you know, and that's a critical component that's missing. So
Right, everything because of Michelson and Morley as a bull excuse.
Well, I don't know. I think a lot of it has to do not just with the Michelson-Morley thing, but also with academia itself. A lot of academia bases their papers on other people's work. They don't do the experiments themselves. And because of that, they throw out terms and they throw out theories. And personally, a lot of their shit you could just throw out. But that's just my opinion, right? The stuff that's being rediscovered are being done by experimenters, not by theorists.
Yeah, because the book doesn't tell you the interaction points with everything. It just tells you a general idea, and then take a general idea and try to apply it to something. It doesn't work at all.
right, and what mainstream or conventional science does is it describes what's going on, but it doesn't do a very good job of explaining what's going on, especially in terms of energy.
Right, no, I absolutely agree with that. So here's the funny thing, like, you can create a warp drive conventionally using only positive energy within relativity, within general relativity. It is possible to create a warp drive. Why Alcubierre needed to use a negative mass is funny, because I think he forgets that you can effectively create a negative mass by comparison of a less positive mass to a more positive mass. You end up getting the same exact effect. And why? Because the vacuum has what we call regaging factor, where it reaches equilibrium. So you can actually use two positive electromotive forces in an interaction pattern to create a differential between mass energy on the front of your craft and the back of your craft, and still create a warp field.
Yeah, it doesn't.
Exactly.
Yeah, charge density, and you just switch your charge density between the back end and the front end, so to speak. That's the way you control it.
Right. So take a look at, like, Gerald's coils, for example. They're a stacked geometry of protonic solids and other sacred geometries. But what you're looking at there is a stacked geometry of higher energy densities and higher curvatures versus lower energy densities and faster velocity. So on the top, you have your fast velocity, you have lower curvature, and your bottom, you have a very high curvature, you have sharper angles, and
Absolutely.
between those two systems, what you're looking at is a field gradient in the refractive index. And it's due to the fact that the physical charges that are flowing through the conductors are having to change angle more abruptly, and they're taking up more space. And as a result, they all have to kind of cross their own fields. So one electron will, move through a conductor at the same time that another electron moves through a second conductor that's at a sharper and sharper angle as they reach the bottom. And what this does is puts a tremendous amount of stress on the refractive index, because each node point, it can only be pointed in one direction at once, but it does have a second property. And here's where this anti-gravity secret is in the second property. Not only can each node physically align or orient, but it can also precess. Because of this precession, the refractive index can modify the local speed of light. And so if you can effectively add enough electromagnetic energy into some unit volume, we already know that, say, the surface of the Earth has a slower speed of light than the distance far away from the Earth. This is basic in relativity. If we add enough electromagnetic energy into a small unit of space, we can create an effective mass that slows down the speed of light. And if the system is a closed or a semi-closed loop where it continues to recycle its own energy, but you're adding external energy from the outside, it reaches a point where the internal speed of light is slowed down enough where you get an energy flow inwards from all directions. And normally we get an energy outflow from gravitational interactions, but in this case we would get an energy inflow, which would mean that this system would lift against the force of gravity. True.
Well, I was keeping that part to myself, but
Not
that's
anymore.
awesome. That's an awesome explanation. You hit the nail on the head there, Jeremiah.
Somebody's got to say it.
It was gonna be said very soon anyway, and this is just like I was saying to Nathan, a precursing teaser before Apex. So yeah, that's awesome that you came on and explained it the way you did.
It's just that, I mean, that's what my research leads me to. That's how I'm looking at it. I've been writing theories for quite a long time, since 2014, and at this point, like, I'm just trying to bring everything into unison. I've met a lot of people like Gerald, Charlie, Jared, Mark, Tim Ventura, Richard Bandurek, Michael Kollick. The list goes on and on. We've got some excellent people in this community, and they're all working towards trying to achieve reactionless propulsion that doesn't operate on this whole rocket idea. So
impulsive technology rather than explosive.
Right, exactly, and that's where you get your inverted thermal equilibrium. That's where basically Lord Kelvin would be rolling over in his grave, because he said you can never convert thermodynamic energy into any other useful form of energy. It's just forever lost. And it's like, literally, look at these systems. They are doing precisely that. So please go kiss off. Lord Kelvin was a brilliant man. He was wrong on this particular point. So you can convert thermodynamic energy, and
Well, I look at it like this. I've used a whole bunch of different instabilities in my system in order to create what's been created. And I believe that anti-gravity is like a set of stairs between here and the upper atmosphere. And all you got to do is dial it in. It may have something to do with voltage. It may have something to do with electrostatics. Maybe it's all of the above. Either way,
Right.
when you dial it in, it should literally be like stairs. When you want to go 10,000 feet, dial it in, hit a button, you're at 10,000 feet. And it's almost instant.
A negative backdraft.
all right, well, this is it's a different kind of potential. Okay, so normally we think of voltage as just simply you can put a multimeter probe on ground and put the other probe on whatever source you're trying to measure, and you get this voltage, right? This is a bit different. This is
It's more like charge.
This is relativistic voltage, and it happens to be in a vector that doesn't produce a classic magnetic field. The magnetic field is actually wrapped up in a loop in this case, so if you try to measure it, you won't be able to. It's completely contained in the loop. But the electric field that the magnetic field generates orthogonally is a real potential that only exists in the physical space, and it's not actually a potential in that physical space based on its geometry that are linked to charges. It is a virtual polarization of the vacuum. So a toroidal wound coil, for example, just like a toroidal transformer, it'll generate, if you put a DC potential into it that's changing over time, a positive on one side and a negative on the other, as far as the actual DC voltage. You can collect this with plates and look at it on an oscilloscope. I've already done experiments and demonstrated this live on multiple occasions. So yeah, you can actually charge a capacitor if you place it in the center of this basic toroidal wound core. Super simple. But the whole idea is it's a virtual charge. It doesn't exist physically because it's bound to the actual charges. They're stuck inside the wire. But their electrical potential that's moving through the physical space has an interaction with the vacuum, and as a result, we get this virtual charge. So the point is that we can react against this virtual charge, and it doesn't have a consequent counter-reaction force on the physical electrons that are moving through the wire, creating this potential.
So would virtual
great way of
charge be
putting it.
considered back EMF?
You're effectively using the back EMF as a traveling wave in the space between the source of the back EMF, which is your toroidal core, and then your electrostatic plates, which are also oscillating in phase with the toroidal peak current.
So it's more like the ether.
Right, exactly. You're using the ether. You're pushing against it. By polarizing it ahead of time and pushing against the polarization, you're not directly interacting with the structures themselves, and so you're interacting with the vacuum, and you don't have to deal with the conservation of momentum due to the fact that the momentum is now quantized within the ether.
Wow.
And this is one of the biggest issues that, especially GPT, does not understand this. The conservation of momentum can be maintained through a very complex set of physics down on the extremely fine scale. But these are not currently part of the paradigm, and even GR can't account for the conservation. So we have to accept that there is actually a much finer structure constituent to this entire equation that's not currently in the mathematics that we have. So QED tried to solve it. There was a variety of different theories that came out from many brilliant minds attempting to unify the extremely fine structure on the quantum scale with the larger macroscopic effects, like physical charges moving through conductors. But to this point, it's still one of those things that in physics, regardless of whether or not we actually have an agreement, which I think actually most of us have kind of an internal mental structure of how this works, the rest of the physics community refuses to accept anything that might bring these factors together. And I think what Gerald said earlier was perfect, which is it comes down to physical experiments. That's what matters. It doesn't matter what your theory is all about. It's physical experiments. I mean, that's what's going to tell us whether this stuff works or not.
Well, they calculated in the wrong energy too. They're basing it on conventional energy sources, not unconventional like electrostatics or peak energy voltage or anything like that. They're just doing basic volts and amps. They have no idea frequency changes both of them, but you know what I mean. They just add numbers in there.
The whole mathematical system is completely incomplete, to say it frankly. It doesn't contain the variation. So if you take the regating problem, which we know has been a continuous issue in mainstream physics. We know that the vacuum will be gauged, but it takes a period of time to do so. What is currently lacking from the equations is the period of time it takes for the vacuum to re-gauge, because right now it's just considered that all interactions are at velocity c. All interactions happen at the speed of light. But that's not actually true.
Yeah, that's not accurate.
Yeah, the speed of light is variable, and we can modify that. So because they don't calculate the complex mathematics involved in how much stress energy you need to add into a local space over a period of time, plus the extra orthogonal signal, there's no way that they can calculate out the velocity of that signal or the redshift or blue shift depending on the energy density. So
honestly, I don't think they're allowed to. They'd lose their funding. There's no university in United States or Canada that would allow any sort of research in this field whatsoever, because this field proves that the ether is real, and that the whole principle behind physics needs to shift 90 to 180 degrees just in order to take that next leap in mankind's history. Now, of course, the powers that ought not be that control everything, including the education system, would never allow that willingly to happen. That's why open source is the only way to make this work. And if it doesn't get open source, then, well, they're just going to pack it down somebody else's dark hole, if you know what I mean, and you're never going to see it again. So it's we all got to work together and get this sucker out.
I guess I would say it this way. Integration into the current education system is something that's not going to happen. The reason is the education system is structured and it's based on very high-level verifiable facts. The books are out of date, and it's basically like trying to learn Newtonian gravity when we understand quantum electrodynamics. And the difference between these are such stark variations. You know, obviously you can't say one apple is equal to another if they have a difference in mass and physical size or volumetric displacement. But in school, you just do calculations in word math problems that say if you have 3 apples, how many of other of these apples do they equal if you take away this many, right? Like, well, you can't really say that, right? Because there are other factors. So the point is that it's simplified. It's so oversimplified and so overstupified, it loses its meaning. And so the only way that this could ever happen is if in the public education system, open sourcing was part of the curriculum. That literally students were encouraged to go and seek outside of the school system in order to find resources about the things that they are most interested in. That's what would have to happen to fix this problem.
Nathan was correct clear. I think algebraic equations are like they're mathematical systems of equality, and over unity, and what we're searching for is like dynamic systems of inequality.
And totally. I also like to emphasize that the math that we have is linear math, and we don't really live in a linear world. There are really no straight lines except for the longitudinal lines that come from the ether, but there are no straight lines in the universe, and we're using linear math to describe a three-dimensional world.
Right,
it's only going to get us about 20% of the way.
It's a zigzaggy path. It really is. It's not a straight line. If you go down to that finest scale, it follows the metric of the physical structure. It doesn't just jump across gaps. It follows a lattice, and it moves around in the curvature of the lattice. So at that finest scale, that's what's really happening. It happens so fast, it's almost inconceivable to us humans. We have no measurement equipment that will ever be able to reach it because it is the physical structure of the universe, and we can't build stuff to measure out of the physical structure of the universe. So we will not be able to measure, but we can at least identify that it exists, because when we test it, the timing of its response quantifies the physical scale that it operates at. And so we can tell that it's not a straight line, but it is a straight line on the macroscopic scale. I mean, that's, people kind of get the wrong idea. I think they think macroscopically, what they really need to understand is that what looks like a straight line is actually a bunch of little zigzags that are traveling in what macroscopically is a straight line.
Yep. It's like looking at the water in your bird bath in your front yard. You think it's perfectly flat, but it's absolutely not.
Right,
Yeah,
exactly.
zoom in. The more you zoom in, the more you notice the subtle differences.
It's like squaring the circle.
Yeah, it's actually
People
got a
say it
bend
can't
in
be
it.
done. Well, I think that's a load of crap. It's just how many straight lines does it take in order to make a circle?
Exactly. That's why the value of pi is currently wrong in terms of the mainstream. You can try to calculate that
For
thing
sure.
out to as many digits as you want, but you'll never get the right value because you can't
Right. As I
quantify a
explained,
circle with a you know.
I've been doing this for close to 15 years, and creating spin is something I've done right from the start. And I understand what linear systems do in comparison to nonlinear systems. And all that means is spin. Nonlinear is spin. So when you're creating a coil, use a series of line inductors and do it as small as possible, and you will create spin. And that's a big key to my work. And it'll come out. Don't worry. Anyway, I'm going to leave it alone. Like I said, when it comes to theory, it's all good. I love it. I don't talk about it much. I've been writing it for a long time. I've got a book. But none of that matters. What it all comes down to is no matter how many scientists are sitting in the room, the first person to make that sucker float, that's what counts. And it's not a race for me. I hope Nathan does it. But all I'm saying is academia, they're great. Pardon my expression, it's like masturbation. It's not the real thing. You know what I mean? Like, it all comes down to, in the end, whoever gets it done, and that's it. Theory ain't going to mean shit. You can do the theory after the system is floating. You know what I'm saying? Sorry if I'm a little cross there, guys.
I'm sorry, but that was funny. That was genuinely funny.
Oh man. Hey guys, by the way, we go back to the ether real quick.
Mm-hmm.
We talk about the magnets on my gravity fly. I got rid of the neodymiums because they're producing heat in the center plate. And when I switched to the regular, like a fringe magnet or a ferrite magnet, it actually improved the entire craft. But it takes a lot longer. So it takes close to 10 minutes to get this thing up to speed. Even with the voltage increases a little bit, it will not do the correct thing without that time.
Resonance?
So what I'm talking about is it won't fill up the bubble. So I'm getting field bubbles out of this thing, and it's holding in the actual high voltage. So it's more of a static energy, and it's holding it in, and you can measure it because it'll interact with the Tesla field voltage and amplify it. And you can see it on my oscilloscope when I do it. Now, I can also see it when I reverse the field and put in the Tesla coil, the spinning disc, and the high voltage the outside. I can push that high voltage all over my garage and create EMF over everything in seconds.
Yeah.
So,
yeah.
Wow.
So I'm creating more of an ether inside the center of this. And Gerald and I were talking earlier when I do my the high voltage experiment, or should I say paper lifter, so it uses electrostatics. I can actually take and put in this thing more pressure than it weighs. So when you say it's like 2 grams that it weighs, right? I can actually get this thing, half a pound in weight just by the pressure I put on it with the electrostatics.
Ooh, I wonder, the replicator, right out of Star Trek. I mean, you're adding weight to it, right? If we have the right resonant frequency for some form of mass, like iron or a chunk of aluminum, or something, that's an interesting thought. Just thinking out loud. Sorry, guys.
That's okay. It's a cavity that does it. It's producing stuff inside the cavity that wasn't there before. So that's creating the weight.
That's awesome.
So just a different way to look at it. That's the way I see it. Oh man,
Hey, Jeremiah, I've stepped
Yeah,
out.
I'm thinking about it. I'm running So I'm a bit quiet at the moment, but I'm running models in my head of various configurations and trying to consider what the actual expansion pressure and refraction pressure are
So
going to
check
be.
it out. Alexi did the thing where he did like infrared, right? He took the light bulb in there and made it red. He actually showed both fields. So you can actually see this thing with the field around it, and it's only around the upper disc, the bottom disc, and the center disc, and maybe like an inch off of it. It's not around the whole craft. So it's creating that field right in there. So it kind of tells you what's going on in the system. He's taking the top disc and bottom disc and he's creating field lines that originally look like they go down, but then they come around the craft on the outside because it's aluminum. It pushes things off and won't let it set inside the metal. So that eddy current forces it out and around, and then that gets pushed out by the Tesla field, and it'll actually create, get my camera, just like that. So it'll create just like that, just like a UFO shape.
Yeah, pretty much. I mean, again, it has to do with the either two factors. You can use, first off, precession, which is preferred of your electric charges, or you can use a rotation of your electric charges, which has other characteristics about it, which you don't want to deal with. But yeah, I mean, precession of the electric charges is really what you're going for there. And it's going to build up the greatest amount of energy that you can actually deal with, depending on their angle, and build up the differential between the electromotive force on the top and the bottom, and therefore a differential in the stress energy momentum of the background vacuum.
I was thinking charge density and charge differential between the top of the paper and the inside cone where it's building.
All right, well, it's also the gradient too. Like if you make the top and the bottom plate of the double-sided cone equal in size, you don't get the same kind of effect. But if you make them unequal, you get this tremendous effect, and that's because there's a gradient in the electrostatic pressure. The charges are distributed across the entire surface, and the field lines want to connect. So in order to connect the field lines, the dielectric has to physically move in order to act as the highest source of connection for all the electric field lines, and therefore it gets pulled up. So it really is about the gradient field drive. And like years ago, I did a APEC presentation on gradient field drives of various types, and I talked about 4 different inventors that had done some various iterations of them. And now we've got more gradient field drives of a new type, thanks to Drew and what is it, Exodus Propulsion. But
Charles Bueller.
Yeah, Charles Bueller too. Exactly right. So they've been doing some excellent work together, and they found another way that you can.
Aren't they doing capacitive and electrostatic lift?
It's capacitive electrostatic force vectoring, not necessarily lift.
You can't create lift with force. It
What's
won't
that?
work. You can't create lift with force.
You mean with electrostatic force?
It's electrostatic force vectoring, and it's interacting with the quantum vacuum. According
That's
to theory.
that to me. That sounds like a capacitor going off in one side and just pushing away from the ether.
That is literally correct. That's exactly right.
And they're getting millibars of pressure.
Well, they're running this whole thing in vacuum, and they're getting micronewtons of force. So
okay, so I'm building a vacuum chamber right now, and what I'm gonna show, well, I guess we'll just see if I get the chamber done by that time. What I want to show is a little bit more than microbars of lift.
Well, yeah, I mean, what we previously talked about goes way beyond any of this kind of quantum vacuum stuff.
Yeah, right.
No, I mean, I kind of hate the term too, because really,
even David Tester said it. He said quantum vacuum is just a bastardized term for ether. They basically ban the word ether.
Exactly, dude. Exactly. Like, no,
that's all it is.
I personally prefer ether. It's what I use, what I write down in my papers. Ether is, I consider the substance the geometric nature of it and its physical interaction with matter. So that's how I consider it. I mean, it either weighs something, the physical vacuum, if you want to call it that, it has a mass. It weighs something. And its mass is what determines the local velocity of light. Light would go an infinite speed if there was no mass in the vacuum. Yeah, basics of relativity tell us that there must be an equivalent amount of energy there present in order to create what we see as the speed of light if we're in that local area. But it also tells us that if there is this modification of the speed of light, that it gets this finite velocity instead of an infinite velocity because of the energy that just exists in vacuum, that there must be some source of why that energy exists and why it can slow down the photons. So in terms of like the idea that was mentioned earlier that there are no straight lines, if every photon has to take this zigzagged path and the length of each little zig and zag, or how many there are between one point and another, are modified, then we would see the speed of light slow down or speed up. But technically, from the outside, we wouldn't actually observe this as a direct change in velocity. We would see it as a redshift or a blue shift. And so that's where we need to be concentrating, is there are subtle changes. We can't actually observe them from a stationary point of reference, but we can understand what's going on there at the fine structure within the vacuum, or what I would prefer to call aether.
They just explained why UFOs go really fast in one direction where you can't see them.
Yeah, basically. They're not at our frequency of light.
They have no impedance.
Yeah, and they have no time.
Yeah.
Yeah, exactly. I mean, you modify the speed of light, and the inside time and the outside time are going to be very, very different things. And if you have a boundary condition at the surface or the shell of the craft, then you're effectively isolated from the outside. So, I mean, if you bump into something and you're traveling at, a relative velocity of, say, 10,000 miles an hour, and you bump into something, you just bounce off of it. That's kind of the result of it.
I think it depends on the velocity that you're going in comparison to the velocity that the other thing you're bumping into is, on which would be diffracted from impact first, so to speak.
Right. Well, if the equilibrium of the shell is 10,000 times slower, then
yeah,
it's still 100 miles an hour. That's still a bit fast. 10 miles an hour is still a bit fast.
I guess I'm thinking about the interaction because I can see this like plain as day in my mind. I love this shit. I'm telling you, I've been studying it for so long. It's great.
Well, that is why we have these think tank meetings.
Yeah, you're not wrong.
Exactly.
I mean, I got the invite to this one from Benefactor, and I'm like, okay, well, I don't know if I got these invites before. I've been kind of busy with life and everything else, but I'll check this one out. This could be interesting. We got some good characters on here. Yeah, by the way, I've been watching your channel, Old Man Builds.
So, oh, really?
Oh, yeah, of course. I work with Charlie C. I work with Jared. I work with David. I work with a bunch of them. Basically, we're part of the core APEC group. And, between myself, Jeremy Riss, primarily Mark Sokol, and Tim Ventura, who have done the most work on APEC, we started the whole conference together, and it's all about doing exactly what you're doing, exactly what we're trying to accomplish here. Reactionless propulsion, finding another way of producing a thrust force that doesn't currently exist in the paradigm that we have now. And we all know it's possible. Like, it exists in the mathematics. It should be possible. It's just a matter of building the right kind of physical device, and that comes down to engineers. You've got to ride that fine line between being a physicist and being an engineer. But if you're not more on the engineering side, chances are it's not very likely anybody's going to reach the correct conclusion.
See, I like your team. I've been kind of watching you guys from behind the scenes sort of thing too, and I think you guys have a great team. But I think replicating all these old experiments are just running you on the same hamster wheel. Hopefully, I'm wrong. You know what I mean? like all these NMR experiments that were done on previously. You guys could be doing way
Oh,
better.
no, I agree
You
with
guys have access to like your lab's amazing. You guys should be having shit float already. And I don't mean that as an insult. I mean like I think you guys are doing great work. You're building the base, right? And then from there, I guess that's where we all leap off.
No, I agree. I do agree. Like the amount of time that, in my opinion, has been wasted on pursuing the wrong avenues is quite tremendous. And we have to acknowledge that, yeah, we've invested a huge amount of time into things that are probably never going to produce fruit. So I'm looking at much simpler ways. Like my primary prerogative in terms of interaction with the group and how I coordinate this is like I'm part of like 3 different groups that all do the same research and we feed each other information. I try to feed out the newest experimental data for everybody to consider so that they can modify their experiments, but we've had pretty good success doing it that way. And the idea is to keep the 3 groups isolated from each other so that they don't get biased. Bias is a huge problem in this arena. And we can see bias in the form of academia, where there's obviously a bias towards what are considered established principles found in the textbooks. We also understand that those textbook principles are way outdated, and they're no longer relevant in this paradigm of cutting edge physics. So
are some of the old academics.
a lot of it is. But nevertheless, we don't need that because we have experiment on our side. And experiment is the most powerful tool in science and physics. It gives us real data that we can verify against what actually happens. And that's the tool that should be used and is unfortunately very underused in current academic sciences.
Yeah, what happened to the scientific experiment? Writing it all out, doing the work and then putting in your thoughts and your comments and getting the job done and then taking that, filing it, getting on to the next experiment. Isn't that how science is supposed to be done?
That is how it's supposed to be done. I mean, the whole scientific method, you're supposed to do experiments, and it's part of the whole process. And it shocks me to think how much mathematicians have spent in terms of their time, energy, and effort writing up stuff that's based on nothing but equations. I mean, it's shocking.
Yeah.
They're brilliant people, too, and their efforts could be so much better utilized if only there was collaboration between experimenters and mathematicians.
Yeah. What? I think I just kind of put things together and see how they work. And then based on those interactions, I go ahead and change things around. And it usually works a lot better that way. I'll let the people do the math later. It's not that I'm incapable of doing it. It's that it's not the time to quantify something before you have something. Because you have to put the, carriage and then you put the horse in front of it. You can't do it any other way. You can't put the carriage in the front. It doesn't work.
Exactly.
Well said.
Man, that was perfect.
Yeah. So, as much as I don't do the energy experiments anymore, like Gerald's working on, and I work on this gravity flyer, it there's a lot of principles that transfer over between all of it. And if I can just get people to understand voltage properly and put all the, little stuff into it so that they can understand, heat changes your voltage from charge to, magnetics. And then you can also remove the heat, you know what I mean? But your frequency would go up. If I can get somebody to understand, the values in that and how energy flows is like a moving bubble. It's not this straight linear line. It's a moving bubble and it's completely different than the way they describe it. So when they quantify things, it's completely on the wrong level because they don't understand that there's an interaction point. It's in constant
Right, again,
motion.
what you're talking about there, Nathan, is the parametric variation in the system. As you add energy to one part of the system, like you add energy to the electrostatic part, but your electromagnetic component and your fixed RPM, for example, you change, then you have a change in the interaction. There's a fine balance between RPM, magnetic flux, distance, acoustic oscillation, and total electric field. And so the whole entire thing has to fall into a state of balance where you end up with waveforms that stack on each other so that they can equal a realistically large potential. And the potential that exists there is massively beyond what you're putting in from your high voltage power supply. It would have to be in order to force that kind of lift. I mean, we were talking, again, maybe 10 kV between the plates, between either positive or negative plate and the center plate. It's not that much. 20 kV, you're really pushing it. You're going to get ionization on the edges. But just looking at the potential, if you look at the addition of this compression and expansion of the aether, then you could have massive amounts of potential, upwards of 300 to 500 kV between those plates in terms of the physical space between them. You wouldn't be able to measure it from the outside very effectively. It would be contained in the bubble. And if you put an instrument into the bubble, you would disrupt its geometry. So you would just sort of have to, I guess, observe it. And thermodynamically, I would imagine that your infrared camera would be able to see a temperature change, and it should look like it's getting cold.
The other day, Nathan and I were talking on his live, and I told him about the hopper and how my coil hopped up 6 feet. And I was looking for my notes, and I found my notes on it. And one thing that I forgot, and I'm pretty sure this goes to temperature, when the coil jumped up and I caught it, and I got the shock of a lifetime. It wasn't a regular shock. It was like hearing sound in every particle in my body. But the after effects was the wild part. I went upstairs, told my wife that, I just got shocked, and I literally sat in the chair and shook. She brought me a blanket because I was cold. And this was in the middle of the summer. So I wonder if that had something to do with it at the time.
Jared, what was your input voltage on that, by the way?
That was actually those plasma globes? So the glass had broken, and I was just using that circuit to run the coil. That's what made it hot. So I believe it's something like 3,000 volts, maybe 27 kilohertz, or it might be more than that. I'm not sure. I had it looked up at one point. But yeah, that's what I was using. Just a simple circuit, 12 volt input to the circuit and 3,000 volts output. Run through the primary and then grounded into the water pipes in my house. And the secondary had a 3,000 or a 3 kV polyethylene capacitor and a high voltage diode on the other end. So it was kind of like an Avamenko plug, but just slightly different, modified. I did it a little differently. So, and that's how it happened. Crazy, I'm telling you.
Yeah, so you're relatively low voltage compared to what I'm putting in this thing. So 3,000 volts, that shouldn't shock you that bad. Not to the point where you were.
Yeah, but see, that's the thing. I believe that my system creates a current or pulls a current in, whichever way you look at it, by the very flow of how the energy wraps and works around the wires in that coil. Because the charge density in the center is way more than the charge density on the outside. So, yeah, and when I grabbed it, when I caught it, I caught the outside and the inside core of the coil at the same time. So it was a lovely little sting.
Yeah, you became the bridge between all of it.
Yeah, well, I grounded out all the energy because I couldn't move. My arm was in the air, and my body was literally frozen. I felt like I was paralyzed until the sound fully went away, and then I could move. and then I started to shake and get cold. So it was a different experience.
Yeah. Wow.
I think you might have infused yourself with some plasmoids there, buddy. They
I
have a
infused
tendency.
myself with something, but I don't necessarily agree with Malcolm Bendall's theory.
Oh, I know you don't agree, but based on his theory, they do have a tendency to steal the heat around them. So keep that in mind.
Yeah. I guess it's like Jeremiah said a while back on a different live with Bernie. If you're the first to come up with the theory, you could call it dog shit if you want. It really doesn't matter, right? You came up with it. It's your theory, But that's not a dig. I'm just trying to be extreme in my example. I apologize.
Would you say that you got shocked by cold electricity then, like the phenomenon that we witness in over Unity devices?
You know what? I don't know what it was. I just know how to describe how it happened. And that's about all I can do, because I've been working on a theory or to try and find a theory for the last 12 years that I've been in the scientific community. And when I asked Bedini and Thomas Bearden that question, and then, I've got so many PDFs and papers on theories and explanations, man, I'm drowning in it.
I can comment on that a bit, Ben.
They all have bits and pieces of what this system does, and at the same time, there's an underlying theory in all of them that makes it all work, and it's all the same. Go ahead, Jeremiah. Sorry.
Oh, no problem. So, was it cold electricity? Yeah, it follows all the parameters that we expect from cold electricity. If he's got a system that is extracting the energy and it throws him, he became part of this conductive circuit.
That makes
the
sense.
system came up from the lab bench and stuck in the air. He was trying to prevent, I think, from crashing down, so he grabbed it from the side. And the way that he grabbed it, he cupped the whole thing like he was holding a glass, and got himself between the inside and the outside, where you have your highest electrostatic potentials. And so, if you get shocked from a plasma globe driver, it's not that horrible. I've got quite a few of them here. I even sent Gerald one controller for a plasma globe driver that he could augment so that he could turn a little knob and vary the output voltage.
Very awesome circuit.
But, ultimately, what was going on there is effectively, was it cold electricity? Very likely. What was described as cold electricity, because in order to form the kind of high power loop and generate the current that could have basically paralyzed him, there would have had to been another factor, a fourth dimensional factor that was not occurring in a normal system. That would be the temporal differential between the inside and the outside. So that's not a potential that you can discharge or collapse. When it exists there, the temporal difference between the rate flow of time, the speed of light in the center, and the outside of the coil, which you grab both at once, would have created a flow of potential between the outside and the inside, and that would have tried to steal charge from the rest of his body, effectively electrifying all of his muscles and putting him into a lock state, kind of like being tasered, basically.
Yeah, actually kind of felt like that, I guess, but there was no pain. Just
the difference is that being tasered, you get pulsed at about 10 hertz, and you can really feel every single pulse. But in this case, you're operating at 15 to 25 kilohertz, and so you don't feel it the same way. You may feel even a warmth in your fingers, even though the coil could feel cold. But it's a different kind of paralyzation, and I built a couple of devices that operate on this as self-defense. I won't use the W word, but yeah, self-defense devices, and they certainly work pretty well in terms of the higher frequencies. And there are papers that relate to showing how the human nervous system responds to this kind of stuff. But yeah, it likely sorry, to answer the question, ultimately benefactor, it was likely cold electricity that he was experiencing in terms of the conventional descriptions that we associate with cold electricity.
I had a hunch. I wasn't quite sure.
Yeah, hey, is Terran Earthling? You got something to present there? He's got something going on here, and I'm looking at.
They're an Earthling. Woohoo!
Yeah.
What's
Okay, so
He's just not answering. Okay.
you there, Taryn? Hey, buddy. Okay, so I'll introduce Taryn Earthling. I don't know if he's having. There he goes. Hey, you here? I see you unmuted. You're gonna have to go into your settings and change your mic. It's not got a mic that we can hear you on yet. So Taryn Earthling is a researcher. In fact, he's one of the best researchers I've ever met. If ever you had a concept or an idea in your mind and you wanted to know, has anybody else ever tried something similar? This guy can find you the papers, the information, the articles in impossible places, and he's done that for me like well over 100 times. So if
Wow.
Darren can get his system working, I'm sure he can pull up relevant information.
Yeah, because he's got a presentation. I can see it. It's just that he hasn't chimed in yet. I thought he would have.
Well,
He
it's
may
cool
be
that you
having
guys are here
microphone
with
issues.
us.
It wouldn't be the first time.
Oh,
I was saying it's cool that you guys are here with us. I really appreciate you guys stopping by and taking time out your schedules and stuff.
Well, yeah, I mean, we were on like I said, I started out this whole entire thing on a meeting, and for most of the show, in the first hour, I was on this other meeting about different types of electrogravitational systems and inertial propulsion systems, and then we got onto this. So, yeah, I'm sorry I missed the beginning, but I'll rewatch it most certainly.
yeah. I don't have your information, or I would have sent you, an invite.
Now, Benefactor sent me an invite.
Yeah,
Yeah,
Ben.
and I attached your email to the chain that I sent out. So Nathan, you should have his email as well if you just look in the.
Okay.
Yeah.
I'll look into it later.
Mm-hmm.
Yeah.
Awesome.
Hey, check it out. You had that experiment on your channel. Let me see what it was. It was the Alexi capacitor, and it was the thing like this, and then
Yep.
you had the stick above it.
Yeah,
Okay.
the wavy capacitor.
Can you explain that a little bit on what you actually saw in there?
Sure. So, if I built up an electrostatic field on the wavy capacitor, and it was pulling on one side of that sitting ruler, that wooden ruler that contained no metal, I would end up getting a force. And I also tried, I think in the video I showed a piece of half-inch by quarter-inch wood that was balanced on a razor blade scale. But anyways, during the point of discharge, the idea is that the charge up is slow, and so the total momentum of the system pretty much equalizes with the environment because the charging is slow. But when you discharge it, you have this sudden change in the gradient produced by the angle of the plate on the top. And so because of this sudden electromotive force that occurs at a gradient, you end up with a repulsive gravitational force, and so the whole ruler or the whole piece of wood pushes away from the gradient, trying to follow the average field lines as they are dispersed into the environment.
So, if I told you that wood got charged up that way when it's on your table, right?
Mm-hmm.
So, would you say if Alexi was using that to understand his craft and the charge in the table, would it then pop off the table?
We tried to get it to do that and never could find a way.
So, you couldn't change the field at all to get it to jump?
Not with electrostatics alone. No, with magnetic fields, absolutely.
So, what if you just changed it immediately? So, for instance, when I run my Tesla coil, right, I want to put it in, how do I say, back pressure or back feeding it, however you want to say that. So it'll actually heat it up and then it'll shoot that heat over to the gravity flyer itself and it'll change the statics into magnetics.
Back EMF.
It's like I'm trying to think of feedback, just like a microphone to a speaker.
Yeah, it's kind of one of the same principles I use in my coil.
I really like the analogy of the speaker microphone feedback loop.
So what I was going to do was I have a megahertz frequency on one part of the coil, and then I have the correct oscillating frequency on the other. I want to put a switch in there so that I can actually make it do that without any other thing. So I automatically force it to not oscillate correctly. So then it heats up the coil. So then when I push the button, I can automatically shove it back into normal mode, force all of that energy out to the gravity flyer and give me the bump.
I just had a thought. Have you ever thought of putting, like when you put your wire down the center of your Tesla coil, you ever thought of putting a coil down the center of your Tesla coil?
No.
That's an interesting idea.
It just popped into my head like, try this. Your frequency.
Like another Tesla coil inside the Tesla coil, or just another
kind of
coil?
more like a pickup coil, but at the same time, I guess it would be kind of like a Tesla coil because it would follow the inside of the whole tube. I mean,
I often
try. Maybe that's the free energy answer that Tesla kept hidden from everybody. Just a thought.
I mean, I often wondered like what would happen if you put a Tesla coil inside a Rodin coil, for instance. You put it at the top or whatever and replace the donut.
I tried that. It acts like a pickup coil.
But
Really?
by the way,
yeah.
We were talking about that, but you could put the number 1 coil inside the number 2 coil and still have it also. Oh, wow.
What about number 3 coil?
Karen Earthman made an entrance.
Sorry.
Oh, my.
Sorry, guys. Mike works.
That's a good one.
Yeah, Mike works now.
Oh, man, welcome.
Welcome. Yeah.
This is like the best entrance ever.
I know, right?
Man, couldn't have done that better. Well, yeah, okay, so your mic works, man. I know you've got documents galore, you've got share screen. What is it that you want to present today?
All right, cool. I'm trying to get through the lines of force for you guys and the dielectric field.
Oh, that would be great.
Yeah, I just wanted to show you guys the dielectric and magnetic field. And
you ready for me to put it up?
Yeah, I'm sharing my screen. So, yeah, sure. So you up?
Go for it. I'm gonna remove us out of there so you can talk.
Yeah, right on. So yeah, this is the so right here, which never really gets shown, but these dotted lines are the lines of force that Eric Dollard always talks about. So the dielectric field is the ones that are going from wire to wire, whereas the magnetic fields are the circles that are going around. Pretty much that's I'm just figured I'd share that. And I don't know if JP is on there because usually he has a lot to say about this kind of stuff.
Yeah,
I'm just wanting to present that because I know everyone's been asking about it.
So yeah, what we're looking at there is you've got your lines that connect between the two terminals. Those are your electric field lines. You've got the circular lines that surround it. Those are your magnetic field lines. And then what you have are these dotted lines, and these are the equal potential lines. And what's really interesting about them is they take into account the variability of the refractive index caused by the stress of the electric potential and the magnetic flux traveling due to current. And so the equal potential lines are never shown in other diagrams. This is one of the only places you'll ever see it. And they are those little dotted lines that sort of form the X in the center. That's basically where the phase angle between the electric field and the magnetic field in terms of its relativistic interaction is exactly at 0 degrees. And this was discovered long before relativity, which is particularly interesting because they knew that there were variabilities there and they were part of the original quaternions in the expanded format, but then were later removed. So,
Yeah, after 1951, everything changed.
yeah.
It was, yeah.
So I saw something like this when Steinmetz showed it. Can you tell me the difference?
Well, Steinmetz shows just the magnetic field and dielectric field right here.
Okay.
So this is, but right here, these are the actual lines of force. I'm sure I believe it's what everyone calls the electromotive force, or a force field, or whatever. I'm not really exactly sure if you would call that a field. I would call that like more like force motion, like because like they're, I don't know.
Effectively, these are
It would be,
electrogravitational lines of force. If you wanted to consider them that way,
yeah.
this is the lines of force that represent the amount of stress and energy that's in the local refractive index.
Of a toroid.
The drawing here is not perfect, and it does have some errors
Yeah.
in terms of the geometry. So I just want to note that if you're looking at this and you're like, your brain is saying, well, that can't be the way that those lines flow, then you'd be correct. But there is a gravitational component that can change the velocity of light in the local refractive index due to flowing currents and an electrostatic potential between conductors that is changing in its rate over time. And so it's where those field lines
Yeah, actually,
overlap, and it's important to understand that where they overlap, you get extra stress, and it can produce this extra or additional force, if you wanted to call it a fifth force. And it comes directly from interaction of matter with the aether.
and these are parallel lines right here. But if you did create a circle, it would pretty much produce similar type of field, like if a toroid. Sorry.
Yeah, mine's slightly different, but I get what you're saying. I do have the two spheres on the inner core chasing each other, but I also have 24 spheres on the outside of the coil that chase each other. It's like 12 positive, 12 negative, so to speak. So I get what you're saying, but yeah, like that would be the basic picture of a toroid, from my understanding. And those dark spots would be like your core, correct? And this would be like kind of like an open core.
Yeah, it's very similar to like oh god, I hate to mention his name, but Ken Wheeler kind of talks about this a bit, but he's very frustrating.
Yeah, I'll second that, man. Wheeler is, oh man, I don't have a lot.
Like I get what he says, but he's definitely frustrating to go upon it and how he teaches.
He's very good at stealing other people's brilliant discoveries and then recontextualizing them in his own words.
There's a lot of scientific people out there like that. He's funny. I watch him with a giggle. You know what I mean?
Yeah, you have to get when you watch him, and you have to pretty much set everything aside and just, take the information that he gives, pretty much.
Yeah, you're like, hopefully he stole it from good sources. Which usually he does. I mean, he's got decently good sources. So.
I'm sorry, I'm howling in the background here.
Well,
it's true, man.
I do understand what you mean by debunking some of Ken's ideas, because I know some of them I'm a little okay, but you got to see from his perspective and do your own research really, and figure it out yourself. Like,
yeah, I mean, a lot
these
of
guys who
ideas
do this are engineers.
Ideas, right? So if Ken's ideas are other people's ideas, and as long as other people's ideas are decent, then he should be good. But he tends to extrapolate a little bit too far sometimes, and so you end up.
Well, I'm going to skim through the very beginning of this document just to because they actually show how they have dielectric particles and magnetic or like little iron filings and mica, I should say, and they show these fields, except for the lines of motion, or the lines of force. So I think that's at the very beginning of this document. So I'll just come up here real quick. And
so I'm not defending Ken Wheeler, but I kind of wonder if it's if it's like coming to the same conclusion over the baseline principle, like the underlying principle, but at the same time using your own language just because you want to call it your own. I just wonder.
Look. Sorry, this guy created the patent. I extracted atmospheric energy and turned it into a ridiculous amount of power.
Okay.
Through a spark gap, and so like it was like a square grid, but in the shape of a triangle, and he was able to extract like
Hey, hey, Taryn, are you
ridiculous
on?
amount of power. And
Hey,
he said he
Taryn.
read this book and figured.
Hey, buddy,
He's
are you
going in
on
and out.
Wi-Fi right now?
It out through here.
Look at every
So-
third word.
Sean,
Okay.
hey, Taryn, hello.
Is he on Wi-Fi or being messed with? That guy, he's got so much info, it's gold. I kind of wonder.
Because
Yeah, but like I said, if you guys want to talk,
Oh wow.
in the
well, my audio, like as I'm listening to you guys talk too, like
You know what?
cut.
Sorry, I think we're gonna let him find it and then come back to it because it looks like he's
your audio's jammed.
Yeah,
find
It's
it
right
there?
here.
Yeah.
Here it is, right here.
Can you get a better Wi-Fi signal?
Yeah, there it is, right there. Oh, yeah, I can see. I know it's blipping in and out. Let's see if I can hook it up to Ethernet. Do I have a thingy? No, I don't.
Physical cable. Yeah, that would do it. Yeah, physical network connection. That should.
Yeah, no, I don't. I don't have the ability for this laptop. Darn.
Yeah,
I know.
I know they stopped including network.
I know it just stopped loading because obviously the Goonies are probably out.
Well, at least we can hear you right now.
There.
Like it's temporarily working,
Okay,
so just run with it.
There it is. Okay. So here he has a mica field, dielectric alliance of force between two, and then figure one, he has the superposition of figure 1 and 2 representing the magnetic field and the dielectric field. So
on
used
the bottom,
mica
on the bottom
in
left,
between
you're looking
to
at the
show the dielectric field, and then they used iron filings to show the magnetic. Yeah. Well, no, the dielectric fields right there, and showing the superposition of the fields, and of course you see the grid, and then yeah. Oh wait, do I get it all messed? Yeah, okay, there it is. Yeah, so yeah, figure 1A. Figure 1B. Yeah. Do you guys see that?
No, we see it. We can't hear you. It keeps
No one's
going
mic's
out.
kicking in. Oh, okay. Yeah, I know. That's generally how it works with everything I try to do online. They don't like the information out. They don't like us to go back and figure out fields.
It's because they know what you have is gold.
Yeah, it explains everything. It teaches you how to engineer what you got, what everyone theory tells.
Yeah, it seems like it's okay when you're not scrolling up and down, but as soon as you start scrolling or trying to show different images, then it completely hesitates. And so, sort of like you have to get to the image, then you have to let it set for a couple of seconds, and then you can talk.
Yeah.
Definitely bandwidth issues, though, for sure.
Yeah. I'm gonna be next time I come on here. I'll make sure I'm hooked up to a computer or something so that I can actually get you guys the proper information faster.
No, it's awesome to see.
Yeah, because and like when we were watching.
I was just say you.
Yeah, that flame jet generator.
Go ahead.
Yeah, we're lagging each other. Okay, yeah. So the flame jet generator. I was trying to tell you guys like some of what Evo was explaining there, or Ivo, sorry, was explaining was actually shown in the flame jet generator that Thomas Townsend Brown was showing on his on the Thomas Townsend Brown family website. Like that toroidal motion that he shows actually gets caught under this convection. I forget what they call it. It's like a lifting shroud, but it's like it gets caught in there, and the flame jet generator is capable of generating like millions of volts. Like it's crazy. Like it depending on the size, obviously, and how much power you put in. But he was explaining that the flame jet generator would shoot out, and he would collect the electricity he needed to generate, and then he would pour that energy back in for flight, and then he would use that flame jet generator to create a vortex ring, so like a toroidal vortex ring under this convection, because plasma follows convection, and then ions also follow convection, and it's just a typical thing that happens. So when Ivo shows that the field does like a circulation where it comes instead of vortexing around, it actually kind of like it circulates. It puts an upward force on that shroud, and he claims that that's the trick to actually getting that real extreme force because it's that vortex ring that's pushing against that shroud, and because the different charges, you're able to charge it up as well. So like the flame jet generator is doing like so many things. It's really cool. You'll find this on the Thomas Townsend Brown website. In fact, Nathan, if you actually have a time where we have like an open mic where with the website, your minds would be blown. Like what he discovered was absolutely fascinating.
Well, I can concur with the flame jet generator definitely, because when Jeremiah had done that experiment, I replicated it. It's insane how that works. I don't even know how, but I never replicated TT Brown stuff. I kind of wonder though, because what you just said, Karen, about how heat follows what was it? Heat follows convection and plasma follows.
No. Plasma follows convection. Ions, I believe, follow convection as well.
Okay,
And
so
what happens is that motion ends up pulling all the plasma and the ions in a circular field and kind of containing it. But it's also creating lift.
So what Nathan and I were talking about earlier about heat and that shift, if plasma follows convection in the same manner, then it makes sense because my coil, it produces like a plasma skin effect on all the copper wires. So what you just said was just as profound as what he said for me. I'm getting the understanding now. Thank you for that.
Yeah. Also in this book is really neat too because it shows you like corona and wires. It shows you the negative and the positive and how they look different. Of course, it's in black and white, so you're not going to get the appeal. But I mean, like if you were to replicate that and actually show that with color, would be fascinating.
The other thing I wanted to mention too is Nathan. You mentioned that you replaced some of your magnets to lower the heat.
Yes.
It may turn out that the heat is actually necessary.
Well, it is, but I'm going to get it from my Tesla coil and not from the magnets. I'm going to flip it in an instant. Like I was telling you, I'm going to get that feedback into that coil, make that number one coil hot, and then I'm going to send it back when I put it back in normal oscillation and feed it back into the center plate, which is cold right now. But as soon as I feed it in there, it's going to turn hot and flip the whole field.
Well, I guess we'll have to see how it works.
It's an interesting concept.
So, like Jeremiah, when you did that flame jet generator, that little one, didn't you say like it could be dangerous because the voltage that was coming out could create like a capacitance charge between objects and yourself, and like if you touch,
well, it was. I mean, it charged up the entire room.
Yeah, you get shocks.
Like, yeah, this is
so I have a decent studio monitor system and speaker setup in my room, and through my audio amp and my grounded system, I was hearing crackling coming through the entire audio. The second that I turned that thing on with the flame, so it penetrates the electronics, it screws with my soldering iron and causes it to go into standby mode and messes with all
Well,
kinds of stuff. I can see white noise on my oscilloscope.
You know, my son complains about the speakers in his room making sound.
yeah, that's probably from your experiments.
Yeah.
I was on live with Jeremiah when he did one of those flame jet experiments. I remember his reaction. Oh shit! So yeah, it's got some juice.
Oh yeah, it was good, man. Like I was so excited that we could amplify voltage with, you know, if you think about the amount of energy in a little turbojet flame, it's roughly about 70 watts to 130 watts in that range thereabouts. So that's the thermodynamic energy that you would have to produce if you could convert electricity into thermal gain in the medium. And anyways, so what we're effectively doing is we're taking the thermal energy, we're stealing it away. If you take a look at some of the older patents, and Sean has these as well, but yeah, there are patents on what's called electrostatic heating and electrostatic cooling, and you can use the flow of charged particles, either electrons in a vacuum environment or ions in a atmospheric pressure environment, in order to add heat or steal heat away from a surface. So, for example, some electrostatic cooling systems are utilized in commercial anodizing for thin materials, where they're passed through an electrostatically charged environment with ions flowing down as they pass along the conveyor belt after coming out of the oven, and they're quickly cooled by electrostatic effect. And so they're charged negatively. The electrons steal the thermodynamic energy from the physical metal that's conducting them, and then they carry it along to the anode, which heats up, but quickly cools down the cathode, which is the part that we're trying to anneal. And so with the annealing process using electrostatics instead, we understand we can steal thermodynamic energy from one place and put it to another. So why should it be any different from the external environment, where we can obviously take a ton of energy and do the same thing with it?
Okay, with that in mind, let me switch this thing real quick. I'm going to show you something. I just want you to evaluate it for me, will you?
Sure.
So, sorry, I'm pushing the wrong buttons here. There we go.
Very manual.
You notice all that vibration in there?
Mm-hmm.
So what do you think's going on?
Well, if I'm looking at the coil that you're winding where your hand is on it, I mean, I see the vibration in that. If you're referring to vibration in a different area,
Well, it's not the coil that I'm winding that's making the problem. It's the coil that all the winding's coming off of, the spool. It's creating a vibration in it, which is shaking the entire table.
okay. Why don't we play that again now that we know what we're looking for?
Okay.
I heard it. Okay, got it. Yep. Yeah, so that is a super classic effect. What's happening is the surface on the inside of the rod, or the outside of the rod compared to the surface of the inside of the spool has tension on it. The spool gets lifted up on the rod, but then the stiction or frictional force that's allowing it to actually stick to the rod loses the amount of surface tension that it needs, which is an electromotive force between the charges of those two different materials, and then it drops back down. And it does that in an audible frequency in the low or ELF range, which we're hearing as this sort of kind of growling sound. So that all of my coil winders do that. It's pretty common. What I do is damp it out where you're holding your fingers there. I use 2 pieces of felt strip that are clamped between some spring nuts, and that allows me to control the tension on the wire, and it gets rid of the vibration problem coming from the spool. But yeah, that's just basic stiction between your center rod and your spool due to the gravitational force and the lifting pressure that's being exerted onto the two.
It's interesting because it's putting a lot of energy into the spool to make that vibration.
It's not a surprisingly large amount of energy. Really, I mean, it's basically it kind of acts like a speaker diaphragm, but I kind of get why you would want to look at this as a possible effect. In this particular case, it's not something to look into, but definitely keep the same open-minded approach to everything else that you see that's odd, like this case, which is kind of unusual, right? You're seeing this effect. I could throw up a spool on the bench right now and basically produce the same thing. It's very straightforward concept, but I don't have to be unspooling the wire. I could just simply spin it with some tension and push it to one side, and it would produce the same effect. And I've seen that in some of my devices as well. I build complicated spool winders and all kinds of stuff. I used to be a motor winder as a career, so I wound big 500 megawatt generators and things like that. So, you know, we've seen all this kind of stuff before. Not to make light of it, but yeah, this is a pretty conventional thing.
Okay, cool. So check it out. I got another video for you. So let me pull it up. I'm very slow at this, by the way.
That's okay. I'm not in a rush.
Have you ever seen this machine? Sorry, when he gets back to it.
Does that have the mercury vortex ball in the center?
Yes. He has a magnetic ball in this one, but he does put mercury. I think I pulled the wrong file.
I think I have the file saved that you're talking about. But yeah, there it goes. We can hear it. Actually, the audio is going through surprisingly well. Wow. Yeah, that's what's up.
Man, that thing's moving.
Yeah.
Sounds like 20 to 30,000 RPM.
Dude, that is awesome. No, it's faster than that.
Maybe 100K.
Oh, he could be getting up there in the 80 range at least.
I'd be worried it was going to blow through that little plastic containment.
So would I, man.
Flying.
So would I.
So, okay, I'll pull up the other one. You guys could talk about it real quick.
It's kind of a cool shaped coil. The concept's different.
Yeah, I can dig it.
Okay, let me see if I can't pull that mercury one.
Sharpie won't stay on.
Yeah.
The readings are all over the place. 30,000, 7,000, 80,000, 20,000, 56,000, 92,000, 73,000, etc. Nothing stable. Maximum is what it's showing, but I don't think there's any degree of accuracy to that. Channel 3.
It's even worse in this configuration. There's nothing holding in the top.
So here we've got
He's brave.
copper ball and child's toy box thing.
The stuff flies
A little
out.
bit, let's say, looking in there earlier, but I think it's probably gone now. But
That is absolutely nuts.
when we bring it close to the spinning magnet,
Oh man.
stealing a lot of the thunder. The magnet's slowing while the copper ball's increasing.
So close to a phase lock,
Yeah.
but not quite there.
Yeah, see, picking up and down a little bit. Let's see, there was one more. I think it had the mercury in it.
That's a brave guy, I'll tell you. This is brave too, actually. Would that not? I kind of wonder. It's just a thought. Would that create pressure, like gas pressure, because it's mercury and flowing? I mean, I don't know.
It creates external pressure that pushes on the outside of the chamber.
That is so cool.
That's ironically exactly what we were talking about in the meeting before I came on this show.
That's
Time to
That's
build
awesome.
one for my coil. No.
I agree with that.
Oh, sorry. You know, it's the configuration too. So I'll just put this back up there.
Sharpie won't stay.
It's the all the different magnetic fields he's got going around this thing.
Yeah, he's compressing them.
So, yeah, I just thought this was really cool. You guys just find it interesting.
No, that's a really cool design. He actually used pyramid design, like a diamond. Like that's, I never thought of that. That's unique.
So I'm gonna bring Ben back in here because Ben, this is what you should do with that little round ball inside of your coil, your rodding coil.
Yeah, by the way, Nathan, people in the comments, they're asking for, whose video this is. And so if you wanted to post a link in the public comments on your channel so that people can, check this out, check this channel out and where you got these videos from.
Yeah, I plan on tomorrow doing a whole video on the channel, but I'll leave it in the description when we're done.
Okay, cool. Just wanted to mention that if you hadn't seen it. Go ahead, Ben.
He actually, I think he put this thing right in the center of Mercury on his channel in a container itself. So it's absolutely amazing.
Yeah, you should play that one again, Nathan. Oh,
Which one? This one right here or the one before?
The Mercury one.
Okay, hold on. Let me find it again. I removed it out of the thing. Oh, I'm telling you, it gets better than that when he gets to the Mercury.
That's just amazing. I wonder if it's the magnetics or the spin itself. Like that's crazy.
It's excellent, isn't it?
Yeah,
now,
imagine if
okay,
it was
so I've done
pressing.
experiments on this, and I would really love to replicate basically what he's done there with one variation, one very big and important variation. So the tube has to be glass, preferably quartz glass, and it's got to be fused perfectly, and the injection port for the mercury has to be on the inside. So under extremely high vacuum, what I've done is, you haven't heard about this one, Nathan. So I'll tell you because you may find this interesting. Gerald knows about this. Taryn knows about this. I took a small 2-inch diameter light bulb and used a torch to remove the end cap to melt that weird kind of material they have that holds it on. Remove the soldering connections, and then at the end I use a diamond Dremel bit to cut off the vacuum input that they pull on the bulb. And then into it I injected about 1/4, U.S. quarter size of mercury puddle in the bottom of this 2-inch sphere, and pulled as high of a vacuum as my pump would allow.
Okay.
I then went into a dark room and completely isolated from all of the light sources, waited about 2 minutes for my eyes to adjust. And then I took the vessel and I spun it around in my hand at a reasonable RPM, not something that's too fast because I'm still a human, my arm and my hand can only move so fast. So I spun it around at a, medium RPM. And where the mercury was flowing around the edges of the vessel of this globe, we were getting a nice bluish purple light that was showing up all around. And this is what we call barometric light, a barometer light. It was first observed when barometers were being transported on a sea vessel, that as the ship rocked back and forth and the mercury that was being pulled on these barometers was shifting, it would produce light at the edges. And they noticed it there, and hence its title barometer light. But yeah, this barometric light, it's produced because the mercury has an extremely high surface stiction, and mercury is in a constantly ionized state. So one of the big secrets about mercury that's never talked about is that mercury, as a room temperature liquid metal, is continuously ionized. In fact, it's for this very reason that it is a liquid at room temperature. It's constantly exchanging charges. It refuses to form bonds. Therefore, it's always in a glassy or liquid state. And even when you freeze it, it starts to form unusual structures, which I'm not going to get into any of the quasi-crystalline stuff today on mercury, but the point being, mercury will generate a huge amount of charge. Enough charge to the point where inside the mercury vessel that I had this light bulb that was pulled vacuum, if you calculate the amount of voltage that will be required to produce visible light at the frequencies that I was seeing, which were ionizing primarily nitrogen, and then we have the ionization also of the mercury itself between the two different spectra that I seen, which is a baby blue and a kind of deep purple that were both overlaid on each other. Those are the two spectra that it was generating as I swirled it around in my hand. If we calculate the amount of energy, we have to be, at least for the vacuum that I had, at over 300 volts of potential. So that means the mercury is generating 300 volts as it flows across the surface and peels away from it. That's pretty significant, I thought. Yeah. And that's just swirling it by hand. So imagine we get the RPMs really up there and we have high vacuum. I mean, what will we expect the system to do? What if it could generate a huge amount of light? And light, of course, is going to have to radiate, so that's going to lose pressure. And following Tesla's dynamic theory of gravity, that's going to cause a contraction of the aether towards the system, right? So
we also have the ancient Vedic texts that describe counter-rotating swirling vortexes of mercury.
So hold on. So you're telling me if I take a tube, a circular tube, and I put a ring of mercury on the top, put one on the bottom, put in the center a coil wire, then I can take that coil wire and get it to generate a field around it. Would I be able to spin it fast enough in order to create a charge around the entire thing if I put it inside of some kind of a chamber that can hold in this energy it's producing.
Well, that's the big catch. See, this has been attempted for many years. A lot of people have tried to do this, and the difficulty comes in trying to get a completely smooth, symmetrical chamber for the mercury to flow around at a very high rate. You also need a material that is completely mercury inert, which generally would be a ceramic or something else of that sort. It's got to have an incredibly smooth surface, not full of pores or atomically uneven.
Would
And
you say the containment has to be spherical, or would it be like cylindrical?
toroidal, imagine
Toroidal,
just a
okay.
donut shape.
Just a donut.
Just a donut. Yep. So it's a very difficult build in terms of the implementation, and then my suggestion of using just pure electromagnetic induction to accelerate the mercury within the chamber instead of having physical electrodes is the primary idea with my approach in terms of how I wanted to do this. But we've got other people that are working on direct MHD types of systems where physical current is passed through the mercury in order to accelerate it as well. And so I don't prefer those systems. They're very high current, high loss, and high heat. I prefer electromagnetic induction directly into the mercury pool. So just like what we've seen in that tube, there are no electrodes. It's completely wireless. It's transferred through magnetic fields, and that's the ideal way to transfer momentum.
That's interesting.
Well, guys, it's almost 9 o'clock where I am, so I am going to get ready to end my stream, but you guys continue. I really appreciate having me on, and I really appreciate everybody for joining us. Nathan, thank you for hosting this great show. Taryn, Exotic Propulsions, Gerald. I didn't expect a lot of people to show up today, to be honest, but this was a great show.
Oh, thanks for the invite. I
Yeah.
appreciate that.
I'll make sure you guys both get it next time too.
I'm gonna jump off at the end of the hour, but I'll stick around until then. And so, I think it was a pretty good show. We covered a lot of topics and got into some technical details, which I think are important for people that are trying to pursue this stuff. So some of them were.
Thanks for being here, man.
But
yeah, thanks, guys.
Feel free to listen multiple times if some stuff was just a little bit too out there. Yeah, there's good info and all of that.
Yeah, JP, it's good to see you in the ring.
Well, everybody, it was a wonderful stream. I really appreciate you guys for coming on and showing us all the love and support. It was a really great show. We had a really amazing set of guests today for our open mic night. With that, we are going to end the stream. So,
wow, you have an amazing audience here. What wonderful ideas and comments. I should join these discussions more often.
Yeah, you missed out today, Lenny. But maybe next stream we'll bring Lenny on. All right. Have a good night, everybody.